In this series of videos, we are going to learn how to use AutoCAD for 2D designing. As you can see, I have already opened the application. Every time you launch AutoCAD, this is what the interface is going to look like. Currently, I'm using the 2023 version of AutoCAD. However, this interface is slightly different in the previous versions. Although there are no major differences and there are exactly the same options, the appearance is a little different. Nevertheless, that won't pose a problem for you as long as you learn how to use AutoCAD in either version. So let's get started. On the left side, we can see the version of AutoCAD we are currently using, and right below we can choose to either open an existing file or to create a new one. To open an existing file, all I have to do is click on the Open button in order for the Select File window to appear. From there, I can browse to the folders of my computer, find the file I wish to open, select it, and click Open on the right side at the bottom of the window. This time, I will just click Cancel since I don't plan on opening a file. Notice that on the right side, recent files appear. Those are files that were recently created, opened, or modified. To put it simply, they are the files you have lately reviewed, so AutoCAD gives you the opportunity to have quick access to them. You do not need to search the path in which those files are saved to open them. If you click on one of those files, it opens immediately. Now, I am going to create a new file by clicking the arrow next to the New button. In this way, a drop-down menu appears from which I can choose the template I want to use for my drawing. In this case, I will click on Browse Templates. The window Select Template, which contains a list with all the available templates, opens. It is highly recommended that among these templates you use either the AutoCAD or the AutoCAD ISO template. The main difference between them is that the AutoCAD ISO template is set up for the metric system, while AutoCAD is set up for the imperial system. So if you're going to draw in metric units, such as meters or millimeters, select this template. And if you're going to draw in inches, select AutoCAD. Once you select the template and click Open, a new file is created. But before I proceed to do that, I will click Cancel to show you something important. If you click directly on the New button instead of the arrow next to it, a new file will be automatically created using the template that was last selected. As you see, the file was automatically created without being asked to choose any template. In this way, I may not remember which template was last used, so it's highly recommended to select the right template for your project before you create a new file. At this point, I will close the new file. Click on the arrow next to the New button and select the AutoCAD ISO template. Then I will click Open. The new file is created and we can see how the interface changes accordingly. In the upper left corner, there is an AutoCAD icon. By clicking this icon, a drop-down menu appears which contains commands for creating new files, opening existing files, saving the current file, importing another file into the current file, exporting this file into a different format, and also printing the file. In addition, there is a list with the recent documents. I will click this icon again to close the drop-down menu. Notice that to the right of this icon there is the Quick Access toolbar, which contains some certain buttons like New, Open, Save, Save As, Open from Web and Mobile, Save to Web and Mobile, Plot, Undo, and Redo. We can modify this toolbar by adding or removing buttons according to our preferences. To add or remove buttons, I will click on the arrow next to the Redo button. I can check the buttons I wish to add and uncheck those I do not need to appear in the toolbar. In this example, I will check the option Workspace. Automatically, it is added to the toolbar. In the same way, I can continue adding buttons as I see fit. Next to this toolbar is the title bar, in which, along with the name of the application and the version we are using, the title of the open document appears. To the right of the title bar, there's a searching field. You can enter any keyword or phrase to search for information about a certain term or command with Autodesk help. And trust me, this might prove very useful no matter how good your AutoCAD knowledge is. For example, let's say I need to find a specific command to remove duplicate lines and arcs. I will type the phrase delete duplicate lines on the search field, and then I will press enter. The Autodesk AutoCAD help window opens, and as you can see, the results that appear are relative with the phrase I wrote. All I need is to find the one that answers my question. In the same way, if we don't remember how a certain tool works, we can type the name of the tool and find the result that corresponds to our need. But now, it's time to close this window and continue with the rest features of AutoCAD's interface. Below the Quick Access toolbar and the title bar is the menu bar. If the menu bar is not visible, as it happens in my case, all I need to do is click on the arrow in the Quick Access toolbar and select Show Menu Bar. Notice that the menu bar appeared. I can hide it again easily if I want to, just by clicking on the arrow in the Quick Access toolbar again and selecting Hide Menu Bar. I won't hide the menu again, since we usually want it to be visible, because there we can find all the tools and commands we need while we are working on a project. Below the now visible menu bar is the ribbon. The ribbon has replaced the toolbars that appeared circumferentially of the drawing area in much older versions of AutoCAD. There, just like in the menu bar, we can find all the tools we need. The main difference is that in ribbon, those tools are represented by icons that make them easy to distinguish. As you can see, those tools are separated in different tabs according to their function. For example, the Home tab has the tools we need to create a 2D drawing. Similarly, in the Annotate tab we can find tools relative to annotation, such as dimensions, explanatory texts, and many more. Now I will return to Home tab. As you may have already noticed, each tab is separated in several panels, each containing a group of tools falling into the same category. For instance, the Draw panel contains tools which are fundamentally used for drawing. Modify panel contains tools for modifying the parts of the drawing, and so on. The Drawing section is the dark area below the ribbon. Every open file appears as a tab at the top of the drawing area, and every one of those tabs shows the name of the open file. On the other hand, at the bottom of the drawing area there is another type of tabs. The first one is the Model tab, which is active right now, and it's where we usually draw. Layout tabs are basically printing layouts that can be adjusted to the units that are used in the model, to the paper and the orientation we are going to print the model into, and last but not least, to the scale we want to print it. As you can see, the layout's background is white, and our drawing, if there was one, would appear in black lines, unless we changed that setting. Back to the Model tab, there is one more important feature, which is the command line. Here we can type the name of any command and press Enter or spacebar from the keyboard to activate it. I would also like to mention the View cube, which can be seen in the right corner of the drawing area, and the navigation bar under the View cube. By clicking a certain side of this cube or one of its arrows, we can change the view of the object. To understand this better, I have opened a simple 3D object that was created in AutoCAD. Right now, we see the top view of the object. I will click on the lower right corner of the cube, and now we see an isometric view of the object. Then, I will click the right view so we can see the right side of the object. To restore the top view, I am going to click the white arrow at the top of the cube and then the rotation arrow pointing to the left to correct the orientation. Now the view is restored as it was in the beginning. As for the navigation bar, like its name indicates, contains tools that have to do with the navigation inside the project and will be explained further in the following lessons. Lastly, if we check the right side of the bottom, we will see a few more icons. This side at the bottom is called status bar. Status bar contains some very useful and helpful tools. When those tools are active, they make the procedure of drawing easier and quicker. However, that doesn't mean that all those tools should be always active. We have to decide when and which of them we need active while working on certain parts of a project. Now that we are somewhat more familiar with the interface of AutoCAD, we are going to elaborate on the different ways we can create a new file. By the end of this lesson, we will have also learned how to save a file so we won't lose our work, and naturally how to open the file we saved. As we have already seen in the previous lesson, once the application opens, on the left side there is the New button with an arrow next to it. By clicking the New button directly, a new file is automatically created using the template that was last selected. On the contrary, if you click on the arrow next to the New button, a drop-down menu appears letting us choose the template we want to use. If no templates are shown, click on Browse Templates. The window with all the available templates appears. At this point, I shall remind you that among these templates you could use either the AutoCAD or the AutoCAD ISO template, depending on the units you are going to draw in. The main difference between the two is that the AutoCAD ISO template is set up for the metric system, while AutoCAD for the imperial system. So if you're going to draw in metric units such as meters or millimeters, select this template, and if you're going to draw in inches, select AutoCAD. Once you select the template and click Open, a new file is created. I will close this new file by clicking on the X symbol of the tab Drawing 1. Another way to create a new file is by clicking the New icon in the Quick Access toolbar. The same Select Template window appears. I will select the template I want, and then I will click Open. Another new file has been created, only this time its temporary name is Drawing 2. I will close this file as I previously did, without closing the application. Similarly, I could have opened the menu file and selected the option New. The last alternative for creating a new file is to click on the AutoCAD icon in the left corner and select the option New. Once again, the Select Template window opens so you can choose a template. After selecting a template, another new file has been created. After creating a file and starting to work on a project, it's only natural that we would want to save the progress of our work. So it's very important to save our file regularly. The first time we save a file, we need to define a folder inside which it's going to be saved. To do so, all I need to do is click on the Save As icon in the Quick Access toolbar. Or I can open the menu file and select the option Save As instead. Either way, Save Drawing As dialog appears and I can browse through the folders of my computer, find the one I want to save the file, and open it. In the File Name field at the bottom of the dialog, I will type the name Test Drawing. Something extremely useful is the Files of Type field. By clicking on the arrow, a list appears which includes older versions of AutoCAD. I can choose to save the file as an older version of AutoCAD so it can be opened by older versions of the application. As for now, I will not change the default option of this field and I will click Save. The file is saved and its name on the tab has also changed from Drawing 3 to Test Drawing. From now on, whatever change I make, no matter how trivial it seems, an asterisk will appear next to the name of the file until I click Save again. To understand this better, I will zoom in slightly. Automatically, the asterisk appeared next to the name of the file. That means that something was changed since the last time I saved the file. To save the progress of my work, I will just click on the icon Save from the Quick Access toolbar, or open the File menu and select Save. Notice that the asterisk has now disappeared. It is going to reappear once I start modifying my drawing again to remind me that I need to save my project. Another detail I would like to mention is that when I first save a file, whether I click Save or Save As makes absolutely no difference. The dialog window Save Drawing As will appear either way because a path where the file will be saved needs to be defined. We can click on Save As even if we have already saved a file, in case we need to save it in a different location and/or under a different name. So I will click Save As, and this time I will select a different folder to save the file. As for the name, I will type Test Drawing 2 and then I will click Save. Now there are two identical yet independent files which I can work on separately. The commands Save and Save As can be also found in the drop-down menu that appears when I click on the AutoCAD icon. From this drop-down menu, the command Save is exactly the same as the one in the Quick Access toolbar. The Save As command, however, has a few more options. I will keep the cursor still for a few moments on the Save As in the drop-down menu and notice that a list with the different options appears. If I choose the option Drawing, then the file will be saved as an AutoCAD file as previously. I can also save this file as a template or as a different format, but I'm not going to elaborate on these options now. I will just close the open file by clicking the X symbol of its tab. As you may have noticed, this is how I can close a file without closing the application. Finally, it's time to open one of the files I created in the previous examples. To open an existing file, we can click on the Open button on the left side of the starting screen. We can also click on the Open icon from the Quick Access toolbar or select Open from the File menu. Alternatively, we can click on the AutoCAD icon and from the drop-down menu, keep the cursor still for a few moments on Open and then choose Drawing from the available options. Whichever way you choose to open a file, the procedure is the same, so feel free to choose whichever you like the best. Personally, I will click on the Open icon from the Quick Access toolbar. The window Select File opens, and I can browse my folders and find the file I wish to open. The same window would have opened no matter where I clicked Open from. I will find the test drawing file, select it, and then click Open. After a few moments, the file is open and ready to be further modified. Once we have created a new file, after selecting the proper template, we have to set the units of our drawing. In this example, I have created a new file based on the AutoCAD ISO template, which is set up for the metric system. Before I begin to draw, it's crucial to set up the format of the units of the drawing and some details such as the precision of the units of measure. All those settings can be found in the Drawing Units dialog, which I can open from the Format menu by selecting the option Units. In case you are not sure where to find the option Units, you can always type the word Units in the command line and then press Enter. As soon as the window opens, you can see that it is separated in different sections. The first section is about length. The Type field displays the format of the units of measure, which can be architectural, decimal, engineering, fractional, or scientific. The most common format is decimal, which is the one we are going to use now. As for the precision, it represents the number of decimal places displayed for linear measurements. In the same way, we can set the format of angles. The most common used format for people who are using the metric system is decimal degrees, so I will leave the angle format set in decimal degrees. The precision field below works the same way as the precision and length. The clockwise option controls whether positive angles are measured in a clockwise or counterclockwise direction. When the checkbox is checked, the angles are measured in a clockwise direction, otherwise they are measured counterclockwise. From the Insertion Scale field, the scale of the blocks and drawings that will be inserted into the current drawing is defined. We are given several options here, such as inches, feet, millimeters, centimeters, meters, kilometers, yards, etc. Typically, we want this scale to coincide with the units we are going to draw in. So, if for example I'm going to draw in meters, I will select meters in this field. Lastly, the lightning option controls the unit of measurement for the intensity of photometric lights in the current drawing. However, this is something that won't affect our 2D drawing in any way, so I won't elaborate on this feature. For now, I will return to the length and angle precision fields to show you exactly what they are meant for. I will set the length's precision to 2 decimal places and angle's precision to 1 decimal place. Now I will click OK to close the window and save the changes I have made. I will select the line tool from the ribbon, which we will learn how to use step by step in the following lessons, and I will create a line of 2000.33333 meters at an angle of 30.533 degrees. Now that I created this line, notice that its length is shown as 2000.33 and the angle as 30.5 degrees, which are correct according to the precision I had previously set. In this lesson, we are going to learn the various ways of selecting objects and the differences between them. In the open document, we can see a simple floor plan. When we wish to select objects individually, all we have to do is move the cursor onto the object we want to select, and when it is highlighted, to click on it. For instance, I will select a chair from the left room of the floor plan. We can keep selecting more objects just like that, by clicking on them once they are highlighted. So I will select the rest of 3 chairs around the table one by one, and then I will also select the table itself. Notice that every time the cursor is on an unselected object, apart from the fact that the object is highlighted, a little plus icon appears next to the cursor. This symbol indicates that there's already at least one object selected and another one is going to be added to the selection. Now imagine that I selected the table by mistake and I wish to deselect it. I will hold the Shift key from my keyboard pressed and I will move the cursor on the table I previously selected. When the cursor is on the table, a little minus symbol appears, which indicates that by clicking on the object it will be removed from the selection. I will click on it and indeed, it's deselected immediately. Naturally, there is no need to keep pressing the Shift key afterwards. Once I no longer need anything to be selected, all I have to do is press the Escape key from my keyboard. All the objects I previously selected are now deselected automatically at once. Up to now, the procedure of selecting objects individually is as simple as clicking on them. However, what happens when we wish to select the objects that are included in a certain area all at once? There are 2 different methods for quickly selecting everything that is included in a certain area. Those are called window and crossing. In both methods, we create a rectangle as large as needed to include the objects we want to select. Imagine that I want to select the table along with the little succulent that decorates it. Starting with window, I will click in an empty space in the upper left corner near the table and then I will move the cursor down to the right. As you can see, a blue rectangle is being created and it's becoming larger the further I move the cursor. As soon as all the items I want to select are enclosed in this rectangle, I will click again. Notice that the objects are now selected. In case I wanted to select the chairs along with the table using window, I should create a larger rectangle to enclose those two. At this point, let's see how crossing works. I will select the table along with the chairs of the right room, but this time I will start by clicking in an empty space in the lower right corner near the table, and then I will move the cursor up to the left. Notice that a green rectangle is being created and all the objects that are enclosed in the rectangle, as well as any object that is crossed by it, is being selected. This means that I don't have to fully enclose all the objects I want to select in this rectangle. I just need to make sure that they are either enclosed in the rectangle or at least crossed by its perimeter. Once all I need is selected, I will click again in the upper left corner near the table. Even though the rectangle I created wasn't large enough to enclose both the table and the chairs, they were still selected. So the difference between the two methods is that by using window, only the objects that are completely enclosed in the rectangle are selected, while by using crossing we select both the objects that are enclosed and the objects that are crossed by the rectangle. Lastly, I would like to mention that from the AutoCAD 2015 version onwards, the selection method lasso was added. To use lasso in either window or crossing mode, I need to keep the click pressed while I draw a free-form area of selection. I will press Escape to deselect everything. Next, I will click near the table and, holding the click pressed, I will draw an area around the center of the left room. To use crossing lasso, I move the cursor clockwise to draw the selection area. Notice that the selection area is green and every object that is being enclosed in this area or crossed by its perimeter is selected. Now, if I want to use window lasso, I could either have moved the cursor counterclockwise from the start, or press spacebar from the keyboard to change it automatically without drawing the selection area again. So I will press the spacebar and notice that now the selection area becomes blue and once again only what is fully enclosed in this area is selected. I will press spacebar one more time while I'm holding the click pressed and notice that a dust line appears showing the path that my cursor curved while drawing the area. This is fence lasso mode and it selects only the objects that are crossed by the path I carve while dragging the cursor around the drawing area. I will release the click and press Escape once more to deselect everything again. Personally, I suggest that beginners avoid using lasso mode until they become familiar with simple window and crossing selection methods.
While working on a drawing, we will need to navigate through it several times to modify the objects that are placed in it. To navigate through the drawing, we use some certain navigation tools, and by certain navigation tools, I'm referring to Zoom, Pan, and Orbit. We can find those tools if we open the View menu as Zoom, Pan, and Orbit. They can also be displayed in the View tab if I right-click, and from the Show Panels options, check the panel Navigate. Notice that the panel is now added to the tab. In addition, they are in the navigation bar under the View cube. In case this bar does not show in your computer, you should go to the View tab of the ribbon and activate the navigation bar button in the Viewport Tools panel. Mine is already activated, so if I clicked on the button, the bar would disappear. Of course, we can type the name of any of these tools in the command line and press Enter to activate them. However, the most common, quick, and convenient way to use those tools is by using the mouse and the keyboard. So to zoom in general, we scroll the wheel of the mouse forward. On the contrary, to zoom out, we need to scroll the wheel of the mouse backward. Notice that every time I scroll the wheel forward, the drawing is being zoomed in, while every time I scroll backward, the drawing is being zoomed out. Now, if I want to zoom to drawing extents, all I have to do is double-click the wheel button. Once the view is restored to drawing extents, all the objects are zoomed in or out up to the point the whole drawing fits the screen size. Now I shall tell you about a little tip for when you want to zoom in on a certain object of the drawing. Let's say I want to see more clearly the plant there is on the left table. I will move my cursor on it, and without moving the mouse any further, I will scroll the wheel forward to zoom in specifically on this item. As I zoom in more and more, eventually I can distinguish the lines of the plant, and I can even modify them if I want. Now imagine that I need to inspect the chair on the left of the table. Of course, I could just double-click the wheel to perform zoom extents and zoom in again with my cursor resting on the chair, but that would take some time to achieve. So, since I'm satisfied with the zoom level and the chair is next to the plant, I will just shift the view without changing the viewing direction or magnification. I will hold down the wheel button and drag the mouse to the right until the chair is almost in the middle of the screen. This tool is called Pan and enables me to move to the left and to the right, as well as up and down in the current view direction and zoom level, or simply put it, enables me to move the view planar to the screen. At this point, I will double-click the wheel to perform Zoom Extents and show you the last basic navigation tool, which is Orbit. I will hold the Shift key down and the wheel button simultaneously and drag the mouse. Notice that the drawing orbits around the green spherical dot that appears in its center. If you also take a look on the view cube, you will see that it also rotates simultaneously with the drawing. By orbiting, the view changes from top to perspective. To restore the top view, I will click Top from the view cube and use the rotation arrows if needed. Now that I have shown you the basic navigation tools, let's see how we can find them in the navigation bar. The first icon is a navigation wheel. Once I click on it, it becomes active, and when I move the cursor in the drawing area, a wheel appears. In this wheel, we can find all the navigation tools I previously referred to. To use them, you can keep the left click pressed on either of them and move the mouse accordingly. In my opinion though, it's not a convenient tool, especially for a beginner, so I will press Escape to deactivate it. The second tool is Pan. Once I click on it and move the cursor in the drawing area, a hand appears. I will click somewhere in the drawing area, keep the click pressed, and move the cursor around. The hand seems to grasp the drawing area and moves it according to how I move the mouse. I will press Escape once again to move on to the next tool, which is Zoom Extents. When I click on it, as we saw previously, the drawing is aligned in the center of the screen and becomes as large as possible to be fully visible. This tool deactivates automatically. Under the Zoom Extents icon, there's an arrow. When I click on it, a drop-down menu appears with various zoom options. From those options, the most useful ones are Zoom Object, which zooms to display one or more objects as large as possible and in the center of the screen, Zoom In and Zoom Out. I won't elaborate on these tools again. The last tool I showed you is under the Zoom Extents icon, and it's the Orbit tool. Once you activate it, you can click on the drawing area and rotate the view. Under the Orbit icon, there's an arrow. A drop-down menu appears again with a few more options for Orbit. I won't elaborate on these tools either, because all the Orbit tools are hardly ever used in 2D drawing. In the same way, you can find Zoom, Pan, and Orbit in the View menu and in the Navigate panel of the View tab. It's a good idea to test how those tools work before you move on with the next lesson, so I suggest that you take some time to practice until you become familiar with them. In the following videos, we are going to learn how to use basic drawing tools. Starting by the Line tool, as its name indicates, is a tool that creates lines. As you can see, I have already created a new drawing. I have purposefully selected the AutoCAD ISO template as I'm going to draw in the metric system, and in addition, I want you to notice something later. Let's begin with the different ways of activating the tool. The Line tool can be found in both the Draw menu and the ribbon if we look at the Home tab and the panel Draw. Naturally, we can just type the word line in the command line and press Enter to activate it. Personally, I prefer using the ribbon to activate these tools, so I will click on the line icon in the ribbon. Once the tool is active, I have to click somewhere in the drawing area to define where the line starts. Notice that a message appears that prompts me to specify the first point of the line. I will click once and move the cursor to the right. Another message appears that prompts me to specify the next point of the line. If I don't care about the length and the angle of the line, I can click on a random spot to define the end of the line. In this example, that's exactly what I'm going to do. Even though the line is created, the tool remains active so I can continue drawing lines. If I want to create solely horizontal and vertical lines, I can restrict the cursor orthogonally by activating the ortho mode from the status bar. In case this icon does not appear in your computer, you can click on the customization icon in the lower right corner and check ortho mode. The icon will appear in the status bar and it will become a lighter shade of blue when it's active. With ortho active, I will click again to create a horizontal line, and then I will click once more to create a vertical one too. As you may have already understood, ortho does not allow me to create a line with an angle different than 0, 90, 180 or 360 degrees. To create a closed profile automatically, I can choose Close from the command line. Before I click Close, I want you to take note that next to that option there is the Undo option. By clicking Undo, you can delete the last line segment you created without deactivating the Line tool or erasing the whole line. You can click Undo if you have mistakenly created a line, but in my case, I do not need to do that. What I want to do, as I said earlier, is to create a closed profile, so I will select Close instead. Once I click on it, a line connecting the first and the last lines I drew is automatically created. Now I have a closed profile. I will select one of those lines and notice that they are indeed 3 independent line segments that can be modified separately. However, what happens when I want to create lines of certain length and angle? I will select the lines I previously drew and press Delete from my keyboard to delete them. I will also deactivate ortho mode so I can move the cursor freely again. Imagine now that I want to create a line that is 5 meters long at an angle of 35 decimal degrees. I will activate the Line tool again and I will click to define the first point in a random place. Then, instead of clicking to define the next point, I will type the number 5 for the length. At this point, I will press the Tab key to activate the Angles field and lock the Length field. Once the active field changes, I will type the number 35 and press Enter. It seems that nothing happened, but in fact the line has been created. In a CAD ISO template, you have to zoom in quite a lot when you're working with numbers under 500. So, to see the line I just created, I will roll the mouse wheel forward until the line appears large enough to see it clearly, and pan to bring the line in the middle of the screen if needed. Now that I can finally see the line, I will create another one. This time the length will be 6 meters, so I will type the number 6 and then press Tab to define the angle, which will be 30 degrees. I will press Enter to create the line and then Escape to deactivate the tool. I can select the Line tool again to create more lines, but before I click on the line icon once again, I want to show you something extremely helpful. In the status bar, there is the icon Object Snap, which is now active. In case this icon does not appear in your computer, you can easily add it to the status bar by clicking the customization icon and checking the option to the Object Snap. Next to the icon there is an arrow. By clicking this arrow, a list with all the available snaps appears. Those snaps can be extremely helpful since they pull the cursor to certain points of the lines and shapes of a drawing. However, they can be extremely confusing when they are all active while working in a large project. In this example, we will learn 2 of them that are related to lines: endpoint and midpoint. The endpoint pulls the cursor at the start or the end of a line segment and is represented by a green square, while midpoint pulls the cursor in the middle of a line segment and is represented by a green triangle. So with those 2 activated, I will select the Line tool again and I will move the cursor close to the end of the second line. Notice that the green square appears, pulling the cursor at the end of the line. I will click on this point to define the first point of the line, lead the cursor horizontally, and type the number 3 to define the length. I will press Enter twice, once to create the line and once more to deactivate the tool. On these terms, if I wanted to create a line started from the middle of another line, I would select the Line tool, move the cursor around the middle of the line, and click to define the start of the line when the green triangle appeared. In this example, though, I won't create another line, so I will just press Escape instead of specifying the next point of the line to cancel the line's creation. So, as you may have already noticed, creating a line in AutoCAD is an easy task, since we are provided with the right tools and some very helpful options to draw with precision exactly the profiles we need. The next tool we are going to learn is Arc, and as its name indicates, it creates arcs. For this exercise, a drawing with some auxiliary lines and points has been created to help you understand the differences between the various ways of creating an arc. As always, we will start with the different ways of activating the tool. The Arc tool can be found in both the Draw menu and the ribbon if we look at the Home tab and the panel Draw. Of course, we can just type the word Arc in the command line and press Enter to activate it. As I have already mentioned, I prefer using the ribbon to activate these tools. Under the icon in the ribbon, there is an arrow. By clicking this arrow, a drop-down menu with all the available ways to create an arc appears. The first option is creating an arc by simply defining 3 points: the starting point, an intermediate point, and an ending point. I will select this one, but before I begin, I will zoom in enough to see the first example better. Then I will open the Object Snap list, which is in the status bar, and make sure that the Node Snap is checked. The Node Snap pulls the cursor to points, and I will need these snaps since, as you can see, certain points have already been placed in the drawing. Now I will click the arrow again and notice that once I'm close to a point, my cursor is being pulled on it. I will click on the first point to start the arc, then on the second to specify a random point of the arc, and then on the third one to end the arc. When the arc is finished, the tool deactivates automatically. I will pan to move the view to the right, and then I will open the Arcs drop-down menu again. This time, I will select the Start, Center, End option. With this one active, I will click on the first point to define the start of the arc, the second will be the center, and the third the end point. However, when my cursor goes to the third point, I notice that this is not the arc I wanted to create. The direction is wrong, so in order to fix that, I will hold the Control key pressed while I click on the third point. The direction changed immediately, and now the arc is as I wanted it to be. The next option I'm going to select is the Start Center Angle option. As you probably have guessed, with this option we define the starting point of the arc, next its center, and finally the included angle. So I will start with the point on the right, then click on the one on the left, and then I will type the number 60 to define the angle and press Enter to finally create the arc. Next on the list is the option Start Center Length. After I select it, I will start with the point on the right, then click on the one on the left to define the start and the center as I did in the previous option. Only this time, instead of the included angle, I will define the length of the arc, so I will type the number 90 to define the length and then I will press Enter to create the arc. Moving on to the next option, which is Start End Angle, I will start by clicking on the starting point, then on the ending point, And finally, I will type the number 150 to define the degrees of the angle. When I press Enter, the arc I created appears. As you can see, this arc was created as simply as that too. Next on the list is the Start and Direction option. With this option, I have to specify the starting point and the ending point of the arc, and finally the direction which the starting point of the arc will be tangent to. So I will click on the right point to define the start, and then on the left to define the end. For the direction, I will make use of the dashed line that has been created in advance. By clicking on the end point of the auxiliary line, the start of the arc becomes tangent to this line. The last option that can be useful is the Start and Radius option. As you may have already understood, I will click on the first point to define the start of the arc, the second point to define the end of the arc, and then I will type the radius, which will be 70 for this example. The moment I press Enter, this arc is created too. The rest of the options in the list are repetitions of the previous ones, except we need to define the center first instead of the start of the arcs. As for the last option, which is Continue, it creates an arc that its starting point is tangent to the ending point of the last arc that was created in the drawing. Since it's not used that often, I won't show you an example of it. The next drawing tool we're going to learn how to use is Polyline. Contrary to line, Polyline creates continuous line segments which are interdependent. Furthermore, using this tool, apart from straight lines, we can also create arcs. Simply put, a polyline can consist of both straight lines and arcs that all are considered as one object. The Polyline tool too can be found in both the Draw menu and the Home ribbon if we look at the panel Draw. Same as every drawing tool we have learned, we can just type the word Polyline in the command line and press Enter to activate it. To draw a polyline, I will click on the Polyline icon on the Home ribbon. Once the tool is active, I have to click somewhere in the drawing area to define where the line starts. Notice that a message appears that prompts me to specify the first point of the line. I'm going to click on a random point of the drawing area to define the start of the polyline. Another message appears that prompts me to specify the next point of the polyline. Since I want to create a line of certain length and angle, I will type the number 100 in the Lengths field, which is currently active, and press Tab to activate the Angles field. Once the Angles field is active, I will type the number 5 and then I will press Enter. At this point, I have to remind you that since I am using the AutoCAD ISO template and the line is rather short, I have to zoom in to see it clearly. The Polyline tool remains active and I can continue creating linear segments. But before I continue, I want you to take a look at the command line. By default, when I select Polyline, straight lines are being created. However, in the command line I am given the choice to change that. I will click on Arc and notice that as I am moving the cursor, the preview has changed from line to arc. The message that now appears prompts me to specify the end point of the arc. I will type the number 70 for its length, then I will press Tab to set an angle of 30 degrees, and finally I will press Enter to create the arc. The arc is created and the tool will continue creating arcs until I change it back to the line from the command line. Before I do that, I want you to take a look at the command line again and notice that there are different options there now. I can choose to specify the included angle by clicking Angle, where the center of the arc is by clicking Center, the direction of the arc by clicking Direction, or the radius of the arc by clicking Radius. However, I won't elaborate on these options because they are the same with those that we have learned in the lesson about arcs. Now, in case I don't know any of the aforementioned values, I can select second point, which is similar to the 3-point arc option. Once I select second point, I need to define a random point of the arc and then its end point. As you can see, by using this option, you don't usually aim for mathematical precision, but it can prove really useful in case you need to imprint an arc from an imported file. In the command line, there are a few more options like undo, which deletes the last segment of the polyline, line, which turns the tool back to draw in linear segments again, and close, which creates a closed loop automatically. I will select undo to remove the last arc I created, and then I will select line. To draw a vertical line, I will turn ortho mode on, and then type the length, which will be 80 meters. Finally, I will click Close to create a closed profile. I will select the profile and notice that indeed, contrary to the line tool, all the segments belong to a single object. Now I will press Delete to remove the polyline I created and show you something interesting you can do with the Polyline tool. I will create an arrow using Polyline. Firstly, I will select the Polyline tool again and I will click on a random place to define the first point of the line. Then, from the command line, I will select the option Width. With the Width option, I can change the thickness of the line evenly, practically increasing the line weight, or unevenly in order to create other shapes. In the command line, a message appears to inform me that I need to specify the starting width. I will type the number 3 and then press Enter. Then I need to specify the ending width of the line, which in this case will also be 3 because I want to create an even, thick line. Now all I need to do is specify the next point or type the length. In this example, I will type the length, so I will type the number 60 and I will press Enter. At this point, a line is created, but I also need a triangle to finish the arrow, so I will select Width again. I will set the starting width 12 and the ending width 0. As you can see in the preview, a triangle has been created, and next I need to define its height and direction. I will lead the cursor upwards, type the number 18 to define the height, and press Enter. Finally, I will press Escape to deactivate the tool and notice how quickly and easily I created an arrow. There's one thing you must remember though every time you use the Width option. The next time you will select the Polyline tool while working on the drawing, you may have to reset the starting as well as the ending width to 0. In this lesson, we are going to learn how we can create circles depending on the data we have available. For the following exercise, a drawing with some auxiliary lines and points has been created to help you understand the differences between the various ways of creating a circle. As always, we will start with the different ways of activating the tool. The Circle tool can be found in both the Draw menu and the ribbon if we look at the Home tab and the panel Draw. As was the case with the previous tools, we can also type the word circle in the command line and press Enter to activate it. As you already know by now though, I prefer using the ribbon to activate these tools. So notice that there is an arrow underneath the circle icon in the ribbon. By clicking this arrow, a drop-down menu with all the available options to create a circle appears. Before I start explaining how every option works, I will open the object snaps to make sure that endpoints, midpoints, and nodes are active. Those are the snaps that I need active right now, so my cursor will be pulled towards the end and the middle of the auxiliary lines, as well as towards the points that have been placed in the drawing. Back to the circle options, with the first one, we can create a circle by simply defining its center and its radius. I will select this option and I will click once to define the center, then type the number 6 and press Enter to specify the radius. The next option is similar to the first one, except that instead of the circle's radius, we need to define its diameter. So I will activate this one, click to define the center again, type the number 12, and press Enter to specify the diameter and create a circle identical with the first one. Next, we will see how we can use 2 or 3 random points to define the boundaries of the circle's perimeter. Let's start with 2 points. Firstly, I will select the first endpoint of the circle's diameter and then the second. And that's it! Another circle has been created. Moving on to the 3-point circle, I will select the same way the 3 points one by one to define the boundaries of the new circle. As you can see, once I select the third point, the circle is automatically created. Lastly, we can create circles that are tangent to lines. There are 2 options for that. Before I show you how they work, I want to point out that for those 2 options, no snaps are necessary. So the first one is tan radius, which creates a circle tangent to 2 lines with a certain radius. And I will select this option. I will move the cursor towards the first line, and when the tangency symbol appears, I will click on the line. I will repeat the same procedure for the second line, and then I will type the number 5 and press Enter to define the radius and create the circle. In the second one, which is tan, I cannot define the dimension of the circle. When I choose this option, I have to click on the 3 lines the circle will be tangent to once the tangency symbol appears. I will click the lines one by one, and by the time I click on the third one, the circle has been created. As you can see, those were all the different options for creating circles. In this lesson, we will learn how we can create an ellipse. The ellipse tool, like the previous drawing tools we learned, can be found in both the Draw menu and the Home ribbon if we look at the panel Draw. Again, we can just type the word ellipse in the command line and press Enter to activate it. As I mentioned in the previous lessons, I prefer using the ribbon to activate these tools. So I will click on the arrow next to the ellipse icon on the Home ribbon to see what are my options. The first option, which is usually the default, is the center option. Once I select the center ellipse, I first have to click and define its center. Then I have to specify the end point of its axis. For this example, I will turn the ortho mode on to help me define the major axis of the ellipse in the x direction and the minor axis of the ellipse in the y-axis direction. I will move the cursor to the right, type the number 500, and press Enter to define the length of the semi-major axis. Then I will move the cursor up, type the number 250, and press Enter to define the length of the semi-minor axis. Notice that the ellipse is created and the tool has been deactivated automatically. Let's see now how the next option works. I will click on the arrow next to the ellipse icon again, but this time I will select the Axis End option. Once active, a message prompts me to specify the first endpoint of the axis, so I will click somewhere in the drawing area to do so. Then, I have to specify the other endpoint of the axis, and by defining the other point, I will define the length of the major axis. So I will move the cursor to the right, type the number 1000, and press Enter. Now, a new message prompts me to specify the distance of the other axis, which is basically the length of the semi-minor axis. This time, I will type the number 250 and press Enter. Notice that an identical ellipse has been created. If I had moved the cursor upwards instead, I could have defined the length of the minor axis and then the length of the semi-major axis. So I will activate the same tool again to show you exactly what I mean. I will click somewhere in the drawing area to define the endpoint of the axis, then move my cursor upwards and set the length of the minor axis 1000. I will press Enter and notice that now the length of the minor axis was defined. Next, I will set the length of the semi-major axis to 250. Once I press Enter, the ellipse is created, and notice that the new ellipse is actually a 90-degree rotated version of the last one. As for the last option, which is the elliptical arc, it's not something we usually use, so I'm not going to show you an example of it. The reason why this option is not usually used lies in its complexity. Furthermore, there are other ways to create elliptical arcs using a combination of the tools Ellipse, Line, and Trim, which is a tool from the Modify panel which we will learn about in the following lessons. Before we finish the lesson, I have to mention that the center snap applies to the ellipse too. So, if for example I wanted to create a line starting from the center of the ellipse, I would select the Line tool first, make sure that the center snap was active, move the cursor onto the ellipse, and once the center symbol appeared, click on it to define the start of the line. In the following lesson, we are going to learn how we can create a rectangle. For this reason, I have already created a new file based on the AutoCAD ISO template. Like we usually do, we will start with the different ways of activating the tool. The rectangle tool can be found in both the Draw menu and the ribbon if we look at the Home tab and the panel Draw. In addition, we can also type the word rectangle in the command line and press Enter to activate it. Like always, I will activate the tool from the ribbon. The first thing I need to do is click somewhere in the drawing area to specify the first corner of the rectangle. Once I click and move the cursor away, I can click again on a random point to define the second corner of the rectangle without specifying its dimensions. After the second click, a random rectangle is created and the tool deactivates automatically. I will select the rectangle again and click to define its first corner. Notice that the length field is active and I can type a number to define it. So I will type the number 100. To lock the length field and activate the width field, I will press the Tab key from my keyboard. With the length field locked and the width field active, I will type the number 80 and press Enter. In this way, I quickly created a 100 by 80 rectangle. Now I will activate the rectangle tool once again. Once the tool is active, I will click to define the first corner and then I will take a look at the command line. There are a few options there. From those options, I will select Dimensions. Now, in the command line appears a message that prompts me to specify the length of the rectangle. I will type the number 100 again, and then press Enter. Then another message appears that prompts me to specify the width of the rectangle. This time I will type the number 80 and press Enter. At this point, the dimensions have been given, but the rectangle has not been created yet. I will move the cursor in the drawing area and notice that the direction of the rectangle changes as I move the cursor. I have to click once more to define the direction in which the rectangle will be created. At this point, I will select the rectangle one last time. I will click to define the first corner again, and then I will select the area option. A new message appears that prompts me to specify the total area of the rectangle. I will type the number 9000 and then press Enter. In order to calculate the dimensions, I need to specify either the length or the width of the rectangle. In this example, I will choose to define the length. More precisely, I am going to set the value to 100. The rectangle is created automatically and its area is 9000 while its length is 100. Similarly, I could have chosen to define the width instead. There are more options in the command line when the rectangle is active, such as chamfer, fillet, width, etc. However, we won't elaborate on them because we don't usually use them. There is another way to create chamfer or fillet, to rotate and to increase the width of the lines in general, and we are going to learn those functions in the following lessons. In the previous lesson, we learned how we can create rectangles. However, next to the rectangle icon there's an arrow. Once you click on this arrow, a short drop-down menu appears, and as you can see, there we can find the polygon tool. The polygon tool can be also found in the draw menu, like the rest of the drawing tools. And of course, we can just type the word polygon in the command line and press enter to activate it. Before I activate the tool, I would like to mention that for the following exercise, a drawing with two auxiliary circles has been created to help you understand the difference between an inscribed and a circumscribed polygon. I also have to mention that for this exercise, the center snap is necessary since I wish the center of the polygons to coincide with the center of the auxiliary circles. Now it's time to finally activate the polygon tool. Once the tool is active, the first thing I have to do is to define how many sides the polygon is going to have. In AutoCAD, a polygon can have between 3 and 1024 sides. Firstly, I will create a hexagon, so I will type the number 6 and press enter to define the number of its sides. Next, a message prompts me to specify the center of the polygon. I will move the cursor on the circle, and once the center snap appears, I will click on it. After the center's definition, I have to choose whether the polygon will be inscribed in the circle or circumscribed about the circle. Let's begin with the inscribed option. I will select Inscribed in Circle and then type the number 10 to define the radius of the circle which the polygon will be inscribed in. Lastly, I will press Enter to create the polygon. Now I will repeat the same procedure, only this time I will select the circumscribed option. I will start by selecting Polygon again. I will press Enter to accept that the polygon will have 6 sides. The number 6 was already written in this field because AutoCAD shows as the default value the last number I had entered in a certain field. I will move the cursor on the other circle, and once the center snap appears, I will click on it. This time, I will select the Circumscribed About Circle option, and then type the number 10 to define the radius of the circle which the polygon will be circumscribed in. Then, I will press Enter to create the second polygon. Notice the difference between the inscribed and circumscribed options. Naturally, there's no need to create auxiliary circles beforehand in order to create polygons. To prove my point, I will activate Polygon again. This time, I want to create a polygon with 3 sides. As you may have imagined, a polygon with 3 sides is basically a triangle. And since it's going to be either inscribed or circumscribed in a circle, it's going to be an equilateral triangle, which means that its sides will have the same length. So I will type the number 3 and press Enter to define the sides. After that, I will click on a random space in the drawing area to define the center of the polygon. Next, I will choose the Inscribed in Circle option and set the radius of the imaginary circle as 10. By the time I press Enter, an equilateral triangle has been created like it was expected. Based on the same principle, a polygon with 4 sides will be a square. With the Polygon tool active once again, I will type the number 4 and press Enter to define the sides of the polygon. Then I will click somewhere in the drawing area to define its center. I will select the Circumscribed option and set the radius of the imaginary circle as 10 again. When I press Enter, a square was created. At this point, I have to mention that in the last 2 examples of polygon, whether I chose the inscribed or the circumscribed option would have made little difference. In the following lesson, we will learn how we can create splines in AutoCAD. In mathematics, a spline is a special function defined piecewise by polynomials. In the computer science subfields of computer-aided design and computer graphics, the term spline more frequently refers to a piecewise polynomial curve. As a computer-aided design application, AutoCAD can create such parametric curves, also known as splines. There are two ways of creating spline curves. The first one is to draw a spline curve which follows certain points, and the second is to draw a spline curve which is intermediate to certain points that basically control the shape of the curve. Those points are also referred to as control points or control vertices. As you can see, a drawing for this purpose has been created, containing some points to help me create the spline curves. Before I activate the tool, I will make sure that the node snap is active, so my cursor will be pulled at the existing points every time I move close to them. The Spline tool can be found in both the Draw menu and the Home ribbon if we click on the arrow of the panel Draw to expand it. As we already know, we can also type the word Spline in the command line and press Enter to activate it. So, to activate the Spline tools, I will click on the arrow of the Draw panel to expand it, and then I will select the first type of spline, which is Spline Fit. With the tool active, I will start clicking on the points one by one. I will click on the first point to specify the starting point of the spline, and then on the next points to gradually create the curve. Every time I click on the next point, another segment of the spline is created. Once I have clicked on the last point, I will press Enter to finish the spline. Notice that a curve that crosses every point I chose has been created. At this point, I will expand the panel Draw again, but this time I will select the Spline Control Vertices tool. I will click on the first point again to specify the starting point of the spline, and then I will start clicking on the rest to define every next point. However, as I specify the next points of the spline one by one, the curve that is being created does not coincide with those points. It is being created somewhere in between instead. This happens because the intermediate points play the role of control vertices. And to be more precise, the control vertices define a control frame to shape the spline. Once I have clicked on the last point, I will press Enter. Notice that automatically the end of the curve coincides with the last point I clicked on. At this point, I will type the word spline in the command line to show you how you can switch from spline fit to spline control vertices from there. When the command is active, I can click on the method menu from the command line and change the type from control vertices to fit and vice versa. I will click on the control vertices option to mention something interesting. As I mentioned in the beginning of the lesson, a spline curve is defined by a polynomial function. I can change the degree of the function by clicking on the degree option in the command line. The default degree of the polynomial function used to create the curve is 3. I will set this value as 1. Now I will create another spline using the same control points I used before. When the spline is finished, it is no longer a curve, but a line. You can experiment with the different results of polynomial functions of different degree and decide which one is the best option for you. In this lesson, we will learn how to place multiple points in a drawing. The Point tool can be found in both the Draw menu and the Home ribbon if we click on the arrow of the panel Draw to expand it. Naturally, we can type the word Point in the command line and press Enter to activate it. As usual, I will activate the Point tool from the ribbon. I will click on the arrow of the Draw panel to expand it, and then I will click on the multiple points icon. Once the tool is active, I can start clicking anywhere in the drawing area to place a point. I will click once, then twice, but notice that nothing seems to happen. The points are barely even visible. I will press Escape to deactivate the tool. Though there's no difficulty in using the tool, there are some settings we should be careful of before we start placing points. To change those settings, I'm going to open the Format menu and click on the Point Style option. The window point style appears with some very important and useful options. First and foremost, I need to define a more distinctive point style. The default option is a dot so tiny that it's not easy to distinguish in the drawing area. In this example, I will choose the circle which has a cross in its center. Any other point style apart from the first two is a good choice if you want to see clearly the points you place. Next is the point size field. The point size plays a major role on how big the points will appear. However, notice that next to the value field there's the percentage symbol. This happens because the option Set Size relative to screen right below is currently chosen. That means that the size of the points will be changing according to the zoom level of the screen. Simply put, when I zoom in or out, the point size will change, something that is not very convenient while working on a project. So it is highly recommended to choose Set Size in absolute units instead, and then adjust the value in the point size field accordingly. Notice that once I set size in absolute units, the percentage symbol next to the point size value field has been replaced by the word units. Now I'm going to change the value from 5 to 50 units and then click OK to see what happens. As you can see, now the points are totally visible and easy to distinguish. Lastly, I have to mention that I can place a point at specific coordinates, which means that I can define the horizontal and vertical distance from the coordinate system's origin. For this example, I have to activate the multiple point tool again. This time I will not click anywhere though. I will move the cursor in the drawing area and notice that there is a message near the cursor which prompts me to specify a point. Next to it, there's an active field which represents the x-coordinate value and an inactive one which represents the y-coordinate value. Notice that while I move the cursor around in the drawing area, the coordinates are constantly changing. To define the coordinates of the point, I will type the number 1500 in the x-coordinate field, and then I will press the comma from my keyboard to switch to the y-coordinate field. The x-coordinate field has been locked, while the y-coordinate field is now active. I will type the number 2000 in this field, and then press Enter. The point is placed automatically, and its distance from the x-axis is 1500 units, while its distance from the y-axis is 2000 units. I will press Escape to exit the command of placing points. I can confirm the coordinates if I select the point and right-click on it in order to open the Properties palette. In the Geometry group, I can see the x, y, and z positions of the point. The x and y positions are indeed the ones I specified previously. In this lesson, we will learn about two quite useful tools, Divide and Measure. For this purpose, a drawing has been created in advance containing the lines, curves, and shapes that are needed for the following examples. Before I continue, let's see how we can activate those tools and what exactly they do. The Divide as well as the Measure tool can be found in both the Draw menu, if I open the Points options, and in the Home ribbon, if we click on the arrow of the panel Draw to expand it. Naturally, we can type either Divide or Measure in the command line and press Enter to activate it. Both tools create points along the length or the perimeter of an object. The difference between them is that Divide separates the length or the perimeter of an object into a specific number of segments, while Measure separates the length or the perimeter of an object into segments of specific length. But it's time to use those two tools in an example so we can understand the difference even better. As I mentioned before, both tools create points, so before I use either of them, I will open the Format menu and click on the Point Style option. By opening the Point Style window, I will make sure that a distinctive point style is selected. If it's not, it's highly recommended that you change the appearance of the points to a different style. I will also make sure that the option Set Size in Absolute Units is selected so the points won't become bigger or smaller as I change the zoom level. Lastly, I will set the point size value as 3 and then click OK. Now I will expand the Draw panel and click on the Divide icon. When the tool is active, a message prompts me to select an object to divide. I am going to select the line first, and then another message appears asking me to enter the number of the segments I want to create. I am going to type the number 5 and press Enter. The tool deactivates automatically, and as you can see, the points are placed so the line is divided in 5 segments. I will repeat the procedure for the curve right below. I will select the Divide tool again. Then I will select the curve, type the number 5, and press Enter. The curve is now separated into 5 segments too. I can also divide the perimeter of shapes like circles, rectangles, and any other closed profile into a specific number of segments. So, at last, I will activate the Divide tool once again, and this time I will select the circle. In order to divide its perimeter in 5 segments, I will type 5 again and press Enter. The circle's perimeter is divided in 5 segments as well. Moving on to the Measure tool, I will expand the Draw panel once more. This time I will click on the Measure icon. Once the tool is active, a message prompts me to select an object to measure. Starting with a line, I will click on it to select it, and then another message appears asking me to specify the length of each segment. In this case, I will type 20 and press Enter. The tool deactivates automatically, and as you can see, the points are placed so the length of each segment of the line is 20 units. Similar to Divide, the Measure tool can be used in curves as well as closed profiles. So I will repeat the procedure for the curve right below. I will select the Measure tool again, select the curve, and set the length to 20 units and press Enter. The curve is now separated into segments of length equal to 20 units each. Finally, I will divide the perimeter of the following circle into segments of specific length. Hence, I will activate the Measure tool one last time. This time, I will select the circle. In order to divide its perimeter in segments of length equal to 20 units each, I will type 20 and press Enter. As you can see, the circle's perimeter has been divided in segments of length equal to 20 units as well. Apart from manually placing points in a drawing, we can also insert multiple points at once from a text file. It is a quite simple and easy procedure as long as we have a text file with the coordinates of each point. As you can see, I have already opened a text file which contains the coordinates of a topo surface. The X, Y, and Z data must be separated by commas, and they should also be in that order. If we are working exclusively in a 2D drawing, then we can omit the Z coordinates. Now all I have to do is to create a new file in AutoCAD, which I have already done, and expand the Draw panel of the Home ribbon to activate the Multiple Points tool. Once active, I will return to the open text file and I will select all the point coordinates. Then I will right-click and from the drop-down menu I will select the Copy option. At this point, I can close the text file since I do not need it anymore. Back in AutoCAD, I will right-click in the command line, and from the drop-down menu, I will select the Paste option.
Since the points I pasted were quite a lot, this might take some time. Once all the points appear in the drawing area, I can finally press Escape to exit the command. The shape of the topo surface is now visible, and if I zoom in, we can distinguish the points one by one. I will zoom out again, and this time I will use the Orbit tool so you can have a better understanding of the final result. While we are working on a project, we may need to place hatches in certain areas to indicate a special feature or a certain trait they have. For this reason, AutoCAD has a hatch tool which provides several different types of hatches. In order to see the hatch types and their options, a file has been created containing the necessary objects for this lesson. But firstly, let's see where we can find the tool. The Hatch tool can be found in both the Draw menu and the ribbon if we look at the Home tab and the panel Draw. Furthermore, we can type the word Hatch in the command line and press Enter to activate it. Like usual, I will activate the tool from the ribbon. The contextual ribbon Hatch Creation with all the available options appears. In the Properties panel, the first drop-down menu is about the type of the hatch. By selecting Pattern, we can select one of the available patterns from the list on the left. In this example, I will select the ANSI 34 and then I will click inside the first rectangle to place it. Once I place it, the contextual ribbon remains active so I can make some more changes to the hatch. Firstly, I can change the type of the pattern and see how it appears in the selected area. I will click on the ANSI 36 and since I like it better, I will set this type of pattern. Next, in the Properties panel from the drop-down menu below the hatch type, I can change the color of the pattern. I will select a baby pink color for this pattern and I will click on Close Hatch Editor to see the result. Now, if I want to further modify this hatch, all I have to do is click on it and the contextual ribbon appears again. I can change the pattern or the color again if I wish, but in this example I will show you how to add a background color instead. So I will go to the Properties panel again, and from the third drop-down menu I will select a blue color for the background. I will press Escape to see the result, and once I'm satisfied with it, I will select the Hatch tool again to create a different type of hatch. In the Properties panel, I will expand the first drop-down menu and I will select the type Solid. A solid hatch is a one-color hatch type. From the second drop-down menu, I will select the light blue color and I will apply it to the second rectangle by clicking in it. Then, I will click on the Close Hatch Editor to see the result and move on to the next example. I will select the Hatch tool one more time to see the last type of hatch, which is the Gradient hatch. Gradient hatch consists of two colors. Once I select the gradient type, I will select a dark blue as the first color and a light purple as the second. From the list on the left, I will select the type GR Sphere and I will click in the third rectangle to place it. At this point, I can close the Hatch editor. As you can see, the two colors are mixed in a spherical pattern. At this point, I have to mention that from the Properties palette, I can also change the transparency, the angle and the scale of a hatch pattern. So in the next three examples, hatch patterns have already been placed, but I'm going to modify them until they appear as needed. I will select the first hatch so the Hatch editor will reappear. In the field of Hatch Transparency, in the Properties palette, I will type the number 70 and press Enter. Then I will close the Hatch editor. Notice that the hatch is now transparent.
Next, I'm going to select the net hats and change the value in the angle field from 0 to 55. The pattern was rotated as soon as I pressed Enter. I will press Escape and select the last hats to show you how to change the scale of the pattern. Notice that in these hats we cannot see the entire pattern. Usually that happens when the scale is not right, so I will change the value in the scale field from 1 to 0.1. Automatically we can see the pattern. At this point I have to mention that you might need to experiment a bit before you decide on the right value in the scale field, which will lead to a satisfying result. I will press Escape again to close the Hats editor and explain to you one more thing about hatches. I will select the tool and once active I will select the pattern type and then the honey pattern from the list. Now, in the Boundaries panel, the default option is Pick Points, which determines the hat's boundary from existing objects. With this option active, I will move the cursor inside the upper area of the rectangle. A preview of the hats inside the automatically detected area appears. I will click on it to place the hats and repeat the procedure for the circle too, leaving only the intersected area out of the hats. Now, to remove the hats from the circle, I have to activate the Remove Boundary Objects button from the contextual ribbon and click on the circle. The hat was automatically removed from the circle and remained only in the rectangle. Next, I will go back to the Boundaries panel and change the setting from Pick Points to Select. With the Select option active, I can select a closed profile to manually determine the boundaries of the hats. In this case, a message prompts me to select an entire object, so I will select the rectangle on the right and notice that the hat is now covering the entire rectangle including the intersecting area with a circle. In this lesson, we will learn how to use some auxiliary tools that help us control the precision of our drawings. Those tools can be found in the status bar, and though we have already used some of them in the previous lessons, in this lesson we are going to elaborate on them. Let's begin with the first tool, which is the 2D object snaps. With this particular tool active, the cursor is being pulled to certain points of the drawing. Firstly, to make this tool appear in the status bar, I will click on the customization icon in the lower right corner and check the 2D Object Snaps option. When the icon appears, I can click on it to activate it. Once it is active, it becomes a lighter shade of blue. Next to the icon there is an arrow. I will click on the arrow to expand the list with the available snaps, and I'm going to activate the end point and the midpoint. The end point snaps the cursor to the start or the end of the line, a curve, or an arc. On the other hand, midpoint snaps the cursor to the middle of a line. With these two active, I will select the Line tool and I will move the cursor to the end of the line that you see in the first example. I will click on the left end point of the line and then on the left end point of the curve to create a line that connects those two endpoints. Next, I'm going to draw a random circle centered at the right end point of the line. Finally, I'm going to connect the middle of the line with the other end of the curve. At this point, I'm going to move on to the next example, so I'm going to reopen the snaps list and deactivate both the end point and the midpoint snaps. I will activate the center and the quadrant snaps instead. The center snap snaps the cursor to the center of circles, ellipses, and arcs. The quadrant snap snaps the cursor to a quadrant point of an arc, circle, or ellipse. In this example, a circle has already been created and I'm going to create a concentric ellipse. So I will activate the Ellipse tool and move the cursor to the circle. Once the center snap appears, I will click on it to specify the center of the ellipse. Then, I will specify the dimensions of the ellipse without typing the exact numbers. Lastly, I will connect the circle's quadrant points with the Polyline tool. So I will activate the tool, and once the symbol of the north quadrant appears, I will click on it. Then I will click on the west quadrant, then on the south, then on the east, and lastly on the north quadrant again to close the polyline. When the polyline is finished, I will exit the command to continue with the next example. Similar to the center snap is the geometric center, which snaps the cursor to the centroid of closed profiles such as rectangles, polygons, and so on. I will activate the snap and deactivate all the rest. Then I will select the Multiple Points tool to place a point in the centroid of each shape. Notice that when the cursor moves onto a closed polyline, a symbol appears in its centroid. I will click to place a point in the geometric center of each shape and exit the command. For the next example, I need only the node and perpendicular snaps active. The node snap snaps the cursor to points, while the perpendicular snap snaps the cursor to a point perpendicular to the selected geometric object. So with those snaps active, I'm going to select the Line tool and specify the start of the line at the point. As for the next point of the line, I will move the cursor to the existing line, and when the perpendicular symbol appears, I will click to specify it. In this way, the two lines are perpendicular to each other. The next snap we are going to learn is the intersection snap, which snaps the cursor to the point where two lines or curves cross. As you can see, there are already two lines that intersect, and I will use their intersection point as the center of the circle I am going to create. So without further ado, I will activate the Circle tool and move the cursor close to the intersection of the lines. Once the symbol appears, I will click to specify the circle center and click once more to create the circle with a random radius. At this point, I should mention that the apparent intersection, which is a little lower in the list, snaps the cursor to the visual intersection of two objects that do not intersect in 3D space, but may appear to intersect in the current view. The next example is about the extension snap. I will activate the extension snap and deactivate the others like I did in the previous examples. The extension snap causes a temporary extension line or arc to be displayed when the cursor passes over the endpoint of objects. In this way, we can specify points on their extension. So, let's say that I want to place a point at the intersection of these two lines. However, they will not intersect unless they are extended. Instead of changing the line's length, I can make use of this snap. So I will activate the Multiple Points tool, move the cursor on the end point of the first line, and as you can see, when I move the cursor, a reference line which indicates its extension appears. Without clicking, I will move the cursor to the end point of the other line and move upwards. Same as previously, a reference line appears. I will move upwards and notice that the point where the two extension lines intersect appears with an X. I will click on it to place a point there. Then I will press Escape to deactivate the tool. Now that we have learned the extension snap, we will see how we can create parallel lines using the 2D object snaps. So I will activate the parallel snap and deactivate the extension snap. Next, I will activate the Line tool and click somewhere near the first line to specify the first point of the line.
Before I continue, I need to identify the line that the new line which I am creating will be parallel to. To do that, all I have to do is hover my cursor on this line, and when the parallel symbol appears, to move the cursor back toward the line that I'm creating. When the path of the line is parallel to the existing line, an alignment path is displayed. I am going to use this path to create a parallel line. Once I'm done, I will deactivate the line tool to move to the next example. When we want to create lines tangent to an arc, circle, or an ellipse, we need to activate the tangent snap. If, for example, I wish to create a line tangent to both circles, I will select the line tool, and with the tangent snap active, I will move the cursor on the first circle. The symbol of tangency appears immediately, and I will click on the side which I wish the line to start. To specify the next point of the line, I will hover the cursor on the second circle and click on it once the tangency symbol appears again. As you can see, a line tangent to both circles has been created. The next snap I'm going to activate and show you how it is used is the nearest snap. Nearest snaps the cursor to the nearest point on an object, such as an arc, circle, ellipse, line, point, polyline, or spline. To give you a clearer idea of what the snap is for, I will place a point on the line. In case I don't care for the exact position of the point and the only thing I want to make sure of is that the point will be placed on the line, this snap is what I'm looking for. So I will activate the Multiple Points tool, and notice that once the cursor goes near the line, the nearest symbol appears. I will click on a random point on the line to place a point. Then I will click again to place another one, and finally deactivate the tool. As you can see, both points are placed on the line. Last but not least is the insertion snap. Insertion snaps to the insertion point of objects such as blocks and texts, and we will elaborate on this snap in the relevant lesson. Before we finish this lesson, I should mention that even though snaps can be very helpful when they are used right, they can be extremely confusing when they are all active in a large project. In the previous lesson, we learned how to use the 2D object snaps. In this lesson, we are going to learn some other auxiliary tools that help us control the precision of our drawings. First and foremost, we will talk about the ortho mode, which restricts the cursor orthogonally. The ortho mode can be found in the status bar. In case this icon does not appear in your computer, you can click on the customization icon in the lower right corner and check ortho mode. Once I activate ortho mode, it becomes a lighter shade of blue. To get a better understanding of what it does, I will activate the line tool and click somewhere in the drawing area to specify the first point of the line. As I move the cursor, notice that the ortho does not allow me to create a line with an angle different than 0, 90, 180 or 360 degrees. I will click to create a horizontal line, and then I will click once more to create a vertical one too. Then I will press Escape to deactivate the tool. So if I want to create solely horizontal and vertical lines, it's easier with ortho mode active. The next auxiliary tool that can be extremely handy is the object snap tracking. This tool tracks the cursor along vertical and horizontal alignment paths from object snap points. Again, if this icon does not appear in your computer, you can click on the customization icon in the lower right corner and check Object Snap Tracking. I will click on it to activate it, and I will also open the snaps list to make sure endpoint and midpoint are both active. As you may have already understood, this tool works in combination with the snaps we learned in the previous lesson. Let's say I want to draw another rectangle that's aligned with the existing one. I will select the Polyline tool, and before I click to specify the first point, I will move the cursor on the upper right end point of the existing rectangle. Be careful, I didn't click yet. Once the name of the snap appears, I will move the cursor to the right and notice that a reference line appeared. Now I can either click on a random point on the line or type a number to define the distance between the two rectangles. In this example, I will type the number 7 and I will press Enter. The first point was specified, so now I'm going to move the cursor to the right, type the number 8, and press Enter to define the width. Next, I will move the cursor downward, type the number 10, and press Enter again to define the length. At this point, I am going to use the reference lines again to create the rest of the rectangle. I will move the cursor on the first point I specified, and once the word End point appears, I will move the cursor down. The reference line combined with the ortho mode snaps the cursor to the right point, so I will click there. Lastly, I will click on the left end point of the upper linear segment and press Escape to finish the creation of the rectangle. Now, I am going to place a point in the center of this rectangle without using the geometric center snap. I will activate the Point tool and I'm going to hover the cursor on the midpoint of the upper side of the rectangle. Once the name of the snap appears, I will move downward and notice that again a reference line appears. Now I am going to hover the cursor on the midpoint of the right side of the rectangle, and once the word midpoint appears, I will move to the left so this reference line will appear too. The center of the rectangle is where the two reference lines intersect, so this is where I will click to place the point. I will deactivate the multiple points to show you one more helpful tool. This tool is called Polar Tracking and it can be found in the status bar too. Polar Tracking, as its name indicates, tracks the cursor along specified polar angles. On the occasion that this icon does not appear in your computer, you can click on the customization icon in the lower right corner and check Polar Tracking. Once I activate it, I will click on the arrow next to it to select the polar increment angle. Let's say that I want to create two lines both starting from the center of the circle. The first line I will create will be at a 30-degree angle from the existing one, so I will select the corresponding option from the list. Then I will select the Line tool and click on the circle center to specify the first point. Notice that as I move the cursor, every 30 degrees a reference line appears. I will move the cursor carefully until the first reference line appears, and when it does, I will type the number 11 to specify the length of the line. At this point, I will exit the line command, reopen the Polar Increment Angles list, and select the option that shows a reference line every 15 degrees. I will activate the Line tool again, and click on the circle center again to specify the first point of the line. This time, as I move the cursor, a reference line appears every 15 degrees. Once I reach 135 degrees, I am going to type the number 11 and press Enter to create this line too. So, as you can see, AutoCAD provides us with some very useful tools which help us draw with precision quickly. While working on a drawing, it's only natural that we will need to modify the elements we have created to fit properly in the drawing. It goes without saying that AutoCAD provides us with the necessary tools for this purpose. The first tool we will learn is the Copy tool.
There are quite a few occasions that copying certain elements instead of drawing them over again is easier and also saves us time. To give you a fuller picture of the way this tool can be used, two simple drawings have been created. As you can see in the first example, there's a room's floor plan. In this room, a bed along with a night table have already been created. However, I want one night table in each side of the bed. Instead of drawing an identical night table on the left side, it's way easier to just copy the one on the right side using the copy tool. The copy command can be found in both the Modify menu and the Modify panel of the Home ribbon. Alternatively, we can type the word copy in the command line and press Enter to activate it. Since we can type every AutoCAD tool and command in the command line, I will not refer to this way of activating the tools again in the future. As soon as the tool is active, a message prompts me to select the item I wish to copy. I will select the night table and then press Enter. Next, I need to specify the base point, namely, the point which I will copy the object from. In this case, the base point needs to be set to the upper right corner of the table, so I will open the snaps list and make sure that the endpoint snap is active. Then I will click somewhere in the drawing area to close the list, and I will set the base point to this particular endpoint by clicking on it. Now, another message prompts me to specify the second point which the table will be copied to. The point I'm going to copy the table to is the bed's upper left endpoint, so I will click on it and move the cursor away. Notice that a copy has been created, but the command is still active and I can continue creating copies of this object. In this example, I do not need to create more copies, so I will exit the command by pressing Escape. As you may have noticed, I can create copies in random places or in certain places. In case I need to copy an object in a certain distance, I can do that easily too. It's time to move on to the second example, where a rounded rectangle has been created. In the upper left corner of the rectangle, there is a circle. Let's say I want to create 3 more circles, one in every corner of the rectangle. The required distances of the circle centers are shown in the drawing. Instead of using the Circle tool 3 more times to create the identical circles, I am going to copy the existing one. Hence, I will activate the Copy command, select the circle, and then press Enter. After selecting the object I want to copy, I have to specify the base point. Before I click anywhere in the drawing, I will open the snaps list and make sure that the center snap is active. Once I do that, I will close the list and then I will set the base point to the center of the circle by clicking on it. Since I intend to copy the circle horizontally, I'm going to activate the Ortho mode too. Next, I have to specify the second point which the circle will be copied to. Since I know the distance between the circle centers, I will move the cursor to the right and type the number 24 to specify the direction and the distance of the second point. The moment I press Enter, the circle was copied. As before, the command remains active, so I will press Escape to exit the command. At this point, I should mention that I can select more than one object to copy at the same time. So to create the remaining 2 circles, I will activate the Copy command again, select the 2 circles, and press Enter. Then I will set the base point to the center of a circle. In this example, it doesn't matter which circle center I choose. Then I will move the cursor vertically and type the number 46 to define the direction and the distance again. I will press Enter to create the copies and Escape to exit the command. The result is exactly how I wanted it to be. There are objects and shapes that are symmetrical, which means they are made up of exactly the same parts facing each other or rotated around an axis. This axis is called axis of symmetry, and it's possible that there is more than one in the same object. When we are drawing a symmetrical object, we do not need to necessarily draw the whole object. We can draw the first part and reflect the identical part to the other side, saving a lot of our time in the process. This particular tool is called mirror since it creates the mirror image of an object based on its axis of symmetry. To get a clearer idea of the way this tool can be used, two simple drawings have been created. As you can see in the first example, there are two simple polyline objects. However, those are only halves of the complete objects. Since the other half of each object is identical to the first one, I have created the axis of symmetry for each one separately. Now I'm going to use the mirror command to create the entire objects. The mirror tool can be found in both the Modify menu and the Modify panel of the Home ribbon. As soon as the tool is active, a message prompts me to select the item I wish to mirror. I will select the first shape and then press Enter. Next, I need to specify the first point of the mirror axis. At this point, I should mention that to specify the first point of the axis, I need the endpoint snap active. So with the endpoint active, I will click on the lower end of the line. Now another message prompts me to specify the second point of the mirror line, so I will click on the other end of the line. Soon after I specified the mirror line, a message appears asking me if I wish the source objects to be erased. In this case, I don't want the initial polyline to be deleted, so I will select No to this message. Once I click No, notice that the polyline is mirrored and now two identical polylines are facing each other. The command deactivates automatically and the profile is now complete. I will activate the mirror tool again to create the reflection of the second object too. As soon as the command is active, I will select the second shape and press Enter. Then, I will specify the first point of the mirror axis by clicking on the upper end point of the line. To specify the second point of the mirror line, I will click on the other end of the line. Finally, in the message that appears asking me if I wish the source object to be erased, I will select No again. The command deactivates automatically, and this polyline is mirrored too. This profile is also complete. At that point, I should mention something very important. It is not necessary to draw the mirror axis in advance, and the reflected object doesn't have to intersect with the initial object. To understand more deeply what I'm saying, I will move on to the next example where a single room's floor plan has been created. A table with the chair has been placed in this room, but in reality, this was meant to be a dining table with 4 chairs. In order to achieve that, I need to place 2 chairs in each side of the table symmetrically. Instead of drawing 3 more identical chairs, I'm going to mirror the one I have already created in such a way so there will be more than 1 chair next to the first one and then 2 on the opposite side. To do so, I will activate the mirror command. Then I will select all the parts of the chair and press Enter. At first, I will mirror the chair on the right side of the table. The mirror axis will be the imaginary line between the 2 midpoints of the table's length. As you have already understood, I need the midpoint snap active for this example. I will click on the midpoint of the upper side of the table to specify the first point of the mirror line, and then on the midpoint of the lower side to specify the second point of the mirror line. In the message that appears, I will select No. Now that the chairs are placed correctly in the upper side of the table, I will repeat the mirroring procedure to create the reflection of them in the lower side. I will activate the command, then I will select both the chairs,
and I will press Enter. As for the mirror line, this time I will select the midpoint of the table's right side and then the midpoint of the table's left side. Of course, in the message that appears, I will select No because I want to keep all the chairs that were created. At last, the dining table has 4 chairs created in the quickest way possible. While working on a drawing, it's only natural that we may need to change the position of several objects we have created or inserted. For example, in the open drawing, we see a single room's floor plan along with a few items. However, those items are in a random place outside the room, so I need to rearrange them. To do that, I will use the Move tool to place them inside the room. However, since I do not intend to move them in random places, I have to be careful to place each one of them in the correct position. For this reason, I will need to activate the appropriate 2D object snaps before I define where the items will be moved. For this exercise, I will need the endpoint snap as well as the midpoint snap active, so I will open the snaps list and make sure they are both checked. To activate the command, I can either open the Modify menu or click on the Move icon, which I can find in the Modify panel of the Home ribbon. Once the tool is active, a message prompts me to select the objects I wish to move. I will select the kitchenette and press Enter. Next, I need to specify the base point, namely the point which I will move the object from. Since I want the left upper corner of the kitchenette to coincide with the internal left corner of the wall, I will specify the base point in the left upper corner of the kitchenette. Lastly, I need to specify the point which I will move the object to. This point must coincide with the base point I previously specified. So in this case, I will click on the internal left upper corner of the wall. As you can see, the kitchenette is now in the right place and the command has deactivated automatically. Next, I will place the countertop next to the kitchenette. I will activate the command again, select the object, and press Enter. Again, I need to specify the base point, so I have to think what point I need to move the object from. I am going to click on the upper right corner of the rectangular item, and once the end point appears, I will click on the internal right upper corner of the wall. At last, I will move the sink in the middle of the countertop. So I will activate the Move tool once more, select the sink, and press Enter. This time, however, I will set the base point in the middle of the upper side of the sink and move this point to the middle point of the upper side of the countertop. Before we finish the lesson, I should mention that I can move an object a certain distance from its original position. To give you an example, I will move the dining table along with the chairs a little more to the left to increase the distance between the table and the window. As you can see, this distance is currently 0.2 meters. So this time I will select all the objects I want to move and then I will right-click on them. From the menu that appears, I will select Move. This is another way to activate the Move command. I will click on the midpoint of the side of the table to specify the base point and activate the Ortho mode to restrict my cursor orthogonally. Then, I will move the cursor to define the direction and type the number 0.5 to define the distance. Once I press Enter, the objects have moved 0.5 meters to the left. Apart from moving objects inside a drawing, it is highly possible that we will also need to rotate those items to fix their orientation. The tool for rotating the objects of a drawing is called Rotate. For this example, I have opened a drawing where a kitchen's floor plan has been created. However, I want to change the direction of the table along with the chairs in such a way
that the back of the chairs will be facing the window. For this reason, I will activate the rotate command. The rotate command can be found in either the Modify menu or in the Home ribbon if we look at the panel Modify. As for me, I will click on the rotate icon on the Home ribbon. Once the tool is active, a message prompts me to select the objects I wish to rotate. I will select the table and the chairs and I will press Enter. Just like the Move and Copy commands, I need to specify a base point. This time, the base point represents the center of rotation, namely the point around which the object will rotate. This point doesn't change direction, so another trick to choose the base point is to think which point you wish to remain in the same position. Since I wish the center of rotation to coincide with the center of the table, I will open the snaps list and make sure that only the midpoint snap is active. Then I will close the list and move my cursor on the middle of the table's upper side. Once the midpoint snap appears, I will wait a few seconds without moving the cursor and especially without clicking. Notice that as I move the cursor downwards, a reference line appears. Now, I will move the cursor to the point of the right side of the table, wait a few moments again without clicking, and then I will move the cursor to the left. Another reference line appears. The point which those two reference lines intersect is the center of the table, and this is where I will click to specify the base point. Next, I need to specify the rotation angle. Since I want to rotate the table set 90 degrees, I will type the number 90 and press Enter. Notice that the command deactivated automatically and the back of the chairs are now indeed facing the window. In the next example, I will show you how to rotate an object when you don't know the exact angle of rotation, but there is a reference line or object you can use for the rotation. As you can see, in this drawing there is a simple room's floor plan. In this room there is a bed. However, the room has been created at an angle, so when the bed was placed in it, the orientation wasn't the same. To fix that, I will activate the Rotate tool, select the bed, and press Enter. However, since I do not know the exact angle, I will use the wall as reference. At this point, I will open the snaps list and activate the endpoint again. Then I will set the base point to the upper left corner of the inner wall. In this way, the bed rotates around this corner, but this is not what I wanted. I want you to look at the command line. There we can find the Copy option and the Reference option. With the Copy option, we create a rotated copy of the object we have selected. With the Reference option, I can rotate an object based on two reference points, which is what I want to do right now. So, after I click on it, I need to specify the reference angle by defining 2 points. I will click on the endpoint of the upper left corner of the bed, and then on the endpoint of the lower left corner to rotate the bed based on that side. Notice that now I can specify the new angle. I will click on the midpoint or the endpoint of the wall, and notice that now the bed is aligned to this wall. When we draw shapes, we can combine different tools to create them, such as the Line tool, the Arc tool, and so on. In this case, the final shape will consist of several independent segments, which in reality are different objects. On the other hand, if, for example, we use the Polyline tool to draw a shape, this shape will be a single object consisting of several interdependent segments. In this lesson, we will learn how to convert independent segments into one object, as well as how to separate the interdependent segments of an object. To have a better understanding of the way these tools can be used, 4 simple shapes have been drawn.
As you can see, each one of the first two shapes consists of several different objects, while each one of the other two shapes is an individual object. Starting by the first shape, I am going to convert these continuous lines and arcs into a polyline. To do so, I am going to use the Join tool. The Join tool can be found in either the Modify menu or in the Home ribbon if we expand the panel Modify. As soon as I activate the command, a message prompts me to select the objects I wish to join. I will select the segments one by one, and then I will press Enter. The command deactivates automatically, and notice that if I move the cursor onto the shape, it has been converted into a single object. I will activate the Join command again to join the segments of the shape below. Since the shape consists of quite a few segments, instead of selecting one by one, I am going to select the entire shape with the window method and press Enter. Notice that this time the perimeter of the shape is joined, while the circle and the slot inside remained two independent objects. This happened because only continuous linear and arc segments can be joined. Let's move on now to the next tool, which has the reverse effect. It converts the segments of a polyline to separate objects. This tool is called Explode, and it can be found in either the Modify menu or the Modify panel of the Home ribbon. When the command is active, a message prompts me to select the object I want to explode. At first, I will select the polyline and then press Enter. This command deactivates automatically too, and notice that if I move the cursor onto the shape, it now consists of more than one object. I will activate the Explode command again to separate the segments of the shape below. I will select it and then I will press Enter. Once again, the shape is no longer a single object, but a bunch of individual lines. There are times when we do not need some parts of certain objects of the shapes we have drawn. When these objects intersect, we can cut the parts we do not need using the point of intersection as a cutting boundary. To do this, we simply have to use the Trim command. To get a better picture of how the Trim tool can be used, a drawing has been created to help me give you some examples. The Trim tool can be found in either the Modify menu or in the Modify panel of the Home ribbon. The quickest way to use this tool efficiently is to activate it and press Enter before I proceed to trim anything. In this way, every object of the shape is a cutting boundary. So without further ado, I will zoom in on the first example to trim the parts I do not need to create the final shape. As you can see, every time I click on a part, the part is being removed. I can click the parts one by one or use the crossing selection to remove more parts simultaneously. When I'm done trimming, all I need to do is press Enter or Escape to exit the command. However, there are times when it's easier to define a center boundary instead of clicking again and again. To prove my point, I will move on to the next example. Let's say I want to trim the horizontal lines up to the second spline they meet. I will activate the Trim tool again and press Enter like I did before. In this way, I have to click at least 2 times to achieve the desired result. I will exit the command and click on the Undo button from the Quick Access toolbar. Now I will activate the Trim tool again, press Enter, and look at the command line. AutoCAD provides us with some different methods for trimming. In this case, I will click on Cutting Edges to set the boundary. Then, I will select the second spline and press Enter. At this point, I am going to select all the lines I wish to trim. Notice that no matter what I select, the lines will be trimmed up to the second spline, which is the cutting boundary. In this way, the trimming process was quite easier and surely quicker. In the last example, I will show you another useful method for trimming objects. Imagine that I want to trim the left vertical line where it was supposed to intersect with the horizontal line if the horizontal line had greater length. For this reason, I will activate the Trim tool again and press Enter. However, when my cursor moves to the line, the application does not let me trim this line. A message appears instead that informs me that the line does not intersect with the cutting edge. In this case, to trim the line, I have to either create a horizontal line that actually intersects with a vertical one, or I can select the Edge option in the command line. In this example, I will select the Edge option and then I will activate the Extend mode. Now, I will proceed to trim the left vertical line again. Notice that I can trim either the upper or the lower part of this line as if the horizontal line actually intersected with it. I will trim the upper side by clicking on it and then I will deactivate the command. When you finish with the Edge option, it is highly recommended that you activate the tool and return the Edge mode to No Extend. The reason I recommend this is because the Extend mode can create confusion when we trim in general, because every object in the drawing that apparently intersects with the object we want to trim will be a cutting boundary. Before we finish the lesson, I should mention that although there are more trim options in the command line, the options that were shown are what you will most likely need. In the previous lesson, we learned how to trim objects to remove the parts of them we don't need. In this lesson, we will learn how to extend objects to increase their length up to another object, which plays the role of a boundary. To increase the length of objects like lines, we simply have to use the Extend tool. To get a clearer idea of how the Extend tool can be used, a drawing has been created in advance. To activate the Extend tool, I can either open the Modify menu or click on the arrow next to the trim icon in the Modify panel of the Home ribbon. When I click on the arrow, a short drop-down menu appears, which includes the Extend tool. I will click on it to activate it. Like the Trim tool, the quickest way to use Extend efficiently is to activate it and press Enter before I proceed to do anything else. In this way, every object of the shape is a boundary that can be used for the extension. So, without further ado, I will zoom in on the first example to extend the horizontal lines. As you can see, every time my cursor moves on a line, a preview of the extension appears. If I click on the right side of the first line, then it extends until it intersects with the vertical on the right. On the contrary, if I click on the left side of the second line, it extends until it intersects with the vertical on the left. I can extend both sides of a line, and I can also extend multiple lines if I select them all simultaneously. Once I extend all the lines I want, I will press either Enter or Escape to deactivate the tool. However, there are times when it's easier to define a certain boundary instead of clicking again and again. To prove my point, I will move on to the second example. Let's say I want to extend the horizontal lines up to the second spline. I will activate the Extend tool again and press Enter like I did before. In this way, I have to click at least 2 times to achieve the desired result. I will exit the command and click on the Undo button from the Quick Access toolbar. Now I will activate the Extend tool again, press Enter, and look at the command line. As happened with the Trim tool, AutoCAD provides us with some different methods for extending lines and curves too. In this case, I will click on the boundary edges to set the boundary over the extension.
Then I will select the second spline and press Enter. At this point, I am going to select all the lines I wish to extend. Notice that the lines extend up to the second spline. That was quite easier and sure enough a lot quicker. In the last example, I will show you another useful method for extending objects. Imagine that I want to extend all the horizontal lines up to the vertical line on the left. I will activate the Extend tool again and press Enter. Notice that the three first lines are extended without a problem, but the last two do not extend at all. If I move the cursor to one of those lines, the message Path does not intersect with the boundary edge appears. So to extend these lines, I have to either create a vertical line of greater length, or I can select the Edge option in the command line. In this case, I will select the Edge option and then I will activate the Extend mode. Now I will proceed to extend the lines again. Notice that I can finally extend the lines. When I'm finished, I will deactivate the command. When you finish with the Extend option, it is highly recommended that you activate the command again and return the Edge mode to No Extend. The reason I recommend this is because the Extend mode can create confusion when we extend lines and curves. Last but not least, I should mention that although there are more methods for extending lines and curves, the ones that were explained in this lesson are what you will most likely need. Another useful tool is the Break at Point tool. With this tool, we can split a line or a curve into two different objects. The Break at Point tool can be found if we expand the Modify panel of the Home ribbon. Once the tool is active, a message prompts me to select the object I wish to break. In the first example, I am going to select the spline. Then I need to specify where the spline will break, so I will click on the point that has been placed on the spline. I should mention that in order to select the point, I need the node snap active. The command deactivates automatically, and notice that there are now two splines that were once part of the same spline. At this point, I will move on to show you another example of how this command can be used. As you can see, this is the top view of a staircase. Usually, in the floor plans, the part of the stair which is below the section of the floor we are drawing is represented by continuous lines indicating that it is visible in the floor plan. On the other hand, the part of the stair that is above the section and is not visible in the floor plan is drawn with dashed lines. Those two parts of the stair are distinguished by a diagonal, and as you can see, each step is indicated by a straight line. Back to the example, let's say I want to change the continuous lines that represent the part of the stair that is not visible in this floor plan into dashed lines. Instead of drawing two different lines for each step that is crossed by the diagonal, I can just split the existing ones into two lines. For this reason, I will activate the Break at Point command. Since the point I want them to split is where the straight lines intersect with the diagonal, I will open the snaps list and activate the intersection snap. In this way, the cursor will be pulled towards the intersection of the lines. I will close the snaps list and select the first line I want to split. Then I will move my cursor near the intersection, and once the X symbol of the intersection snap appears, I will click on it. The command deactivates automatically, and notice that the line I selected is split into two lines. I will repeat the same procedure for the last step of the stair that is crossed by the diagonal. I will activate the Break at Point tool again and select the second line. Next, I will click on the intersection point, and as you can see, once again, the line has split into two lines.
Finally, I am going to select all the lines that I want to be dashed and change their type from continuous to hidden. We're going to learn how to change the line type in more detail in the following lessons. So, to sum up, in some cases, splitting lines and curves in a certain point is way easier and quicker than drawing each part individually over again. Sometimes we need to create rounded or flattened corners in our drawing. In AutoCAD, we can convert a simple corner to a rounded corner with the fillet tool. We can also convert a sharp corner to a sloped or angled corner with the chamfer tool. To understand how the fillet and chamfer tools can be used, two drawings with some examples have been created in advance. I should mention that the fillet as well as the chamfer tool can both be found in either the Modify menu or in the Modify panel of the Home ribbon. Firstly, we need to learn how the fillet tool works. Once I activate fillet, I have to define its radius. So I will click on the radius option in the command line, and as the shape on the left indicates, I will type the number 22 and press Enter to specify the radius. Then I will select the horizontal line first and then the vertical line. The fillet is finished and the command deactivated automatically. Moving to the next example, I will show you how to perform multiple fillets without activating the command over and over again. I will activate fillet and click on the multiple option in the command line. Then I will click on the radius option, type the number 10 and press Enter to specify it. I will select the two lines of the corner and notice that even though the corner becomes rounded, the command remains active. I will select the radius option again, type the number 5 and press Enter to specify the new radius. Then I will select the rest of the lines of the corners I want to become rounded. Once I no longer need the fillet tool, I will press either Enter or Escape to deactivate it. I will move to the last fillet example to show you something quite interesting. We can perform fillet in arc and circles too. With the fillet tool active, I will set the radius to 19 and select the multiple option. Then I will select the right side of the small circle first and then the right side of the bigger one. I will repeat the procedure for the left side and notice that now the two circles are connected by two arcs which are tangent to both circles. At this point, I will move on to the next drawing to show you how the chamfer tool works. We can chamfer a corner using two different methods. We can either specify the horizontal and vertical distance of the chamfer, or we can specify one of the two distances and the angle. But let's see the difference in an example. In the first example, I will activate the command, and then I will select the distance option in the command line. Now a message prompts me to specify the first chamfer distance. I will type the number 5 and press Enter. Then another message prompts me to specify the second chamfer distance. This time I will type the number 10 and press Enter. Next, I will select the horizontal line of the corner first and then the vertical line. The chamfer is finished and the command deactivated automatically. Notice that the first distance was applied to the line that I selected first, while the second distance applied to the line that I selected last. In the next example, I will activate the chamfer tool again, but this time I will select the angle option in the command line. Again, a message prompts me to specify the first chamfer distance, so I will type the number 12 and press Enter. The second message prompts me to specify the chamfer angle from the first line. So I will type the number 30 and press Enter. All I have to do now is select the first line and then the second.
Once again, the command deactivated automatically. Lastly, I will show you how to perform multiple chamfers without activating the command over and over again. So, once I activate chamfer, I will click on the multiple option in the command line. Then, I will click on the distance option and I will set the first distance to 10 and the second to 5. I will chamfer the left upper angle and notice that the command remains active. So I will also chamfer the lower right corner and then I will press either Enter or Escape to deactivate the command manually. Changing the size of the objects proportionally is something that we may also need to do a couple of times while working. For example, we may need to enlarge an object in a way that it will be double in size. By the same reasoning, we could also reduce an object's size, let's say to half of the original size. To do so, we will use the Scale tool. The Scale tool can be found either in the Modify menu or in the Modify panel of the Home ribbon. Once I activate the tool, a message prompts me to select the object I wish to scale. I will select the item that has been drawn in the first example and press Enter. Another message appears which prompts me to specify the base point. I will click on the lower left corner of the shape I selected to define it. Next, I have to define the scale factor. Notice that as I move the cursor, the size of the shape changes accordingly. In this example, I want to reduce its size to half, so I will type the number 0.5 and then I will press Enter. As you can see, the object now is smaller. I will activate the command again, select the same object and press Enter. I will set the same base point as before and look at the command line. I am given two options, the Copy option and the Reference option. By selecting Copy, the scaled object will be a copy of the original, while the initial object will remain the same. So I will click on the Copy option and notice that now the preview that appears as I'm moving the cursor does not affect the object I have selected to scale. This time, I want to create an object 3 times bigger than the one I selected. So I will type the number 3 and press Enter. As you can see, the scaled object is indeed a copy and the initial object has not changed. Moving on to the next examples, I'm going to show you how the reference option works and how we can use this option in a project. As you can see, in this drawing, there's a simple room's floor plan with a bed in it. Let's say I want to scale the bed in such a way that its upper side reaches the wall. I will activate the Scale command, select the bed, and press Enter. I will set the base point to the lower left corner of the bed. In this case, though, I do not know the exact scale factor that will enlarge the bed as much as needed to reach the wall. To make this work, I need to use a reference in combination with the intersection snap. So I will activate the intersection from the snaps list, and then I will click on the reference option in the command line. I will use as a reference the left side of the bed, so I will click on the lower left corner first, and then on the upper left corner. Now the bed size is increasing using as a reference the length of the bed. In this way, when the cursor goes close to the wall, the intersection snap appears. When I click on it, the bed size adapts accordingly and the result is exactly what I wanted. Now, let's see another example where I'm going to use the reference option. Imagine that you have imported a drawing someone else created into your drawing, and the size of the items is not right. To give you a better picture of what I mean, a ship's hull has been imported in the current drawing. However, the length of this boat doesn't seem right. I already know that its length should have been 19 meters, but as you can see, it is a lot bigger than that.
I can scale it, but unfortunately I do not know the scale factor. Since I know its current length, which is equal to 26.68 meters, and its actual length, which is equal to 19 meters, I could make some calculations to figure the scale factor out. However, that would take some time to achieve. So I can use its length as reference and define the new length while scaling it. To do this, I will activate the Scale tool, select the boat, and set its base point on the left side of the deck. Then I will type Ref to activate the reference option and click on the two endpoints of the deck. Finally, I will type the number 19, which will be the new length, and press Enter. The scale process is finished, and now the boat is indeed 19 meters long, as it should be. There are quite a few cases that we want to lengthen an object without changing its size in general. This can be achieved if we use the Stretch tool. The Stretch tool can be found either in the Modify menu or in the Modify panel of the Home ribbon. In the first example, the distance between the two circle centers is 20 centimeters. However, I realized after having created them that the distance is wrong. The centers should have been 25 centimeters apart. To correct that, I will activate the Stretch tool. A message prompts me to select the objects I wish to stretch. I will select the parts I want and press Enter. Then, I need to specify the base point. I will set the base point to the center of the circle and proceed to move the cursor to the right. However, as you can see, the shape isn't being stretched, it is being moved instead. This happened because the only way to perform stretch is to select the object using the crossing method. If I select them by clicking on them one by one or by using the window method, as I did, I will only move the objects. So I will press Escape and activate the Stretch tool again. This time, I will select the objects using the crossing method, set the base point to the center of the circle again, and move the cursor to the right. Notice that now the shape is stretching. All that is left is to define the extra length, so I will type the number 5 and press Enter. The command deactivates automatically and the result is now correct. At this point, I should mention that when you wish to stretch an object, the extent of the crossing window plays a major role on what part of the shape will be stretched. To get a clearer picture of what I mean, I want you to take a look on the following picture to understand the different results according to the extent of the selection. As you can see, the part of the shape that is being stretched depends on the junctions that are included in the selection. Based on what we have already learned about the Stretch tool, let's move on to another example. In this floor plan, there are two windows. Imagine that I want to stretch the vertical window so it becomes 2 meters long. To do that, I will activate the Stretch tool again. I will select the upper side of the window and with the Shift key pressed, I will remove the walls from the selection. Then, I will set the base point to the upper right corner, move my cursor upward, and type the number 1. As you can see, as soon as I pressed Enter, the window became 2 meters, but the walls remained as they were. I will click on the Undo icon from the Quick Access toolbar to return to the point where the window was not stretched yet. Now I will repeat the procedure, but this time I will let the walls be part of the selection. Setting the same base point again, I will move my cursor upward, type the number 1, and press Enter. Notice that now the walls have shrunk in proportion to the stretch of the window. Another useful tool in AutoCAD is the offset tool. Contrary to the copy tool, which creates clones of objects at a specified distance and direction, offset creates a new object whose shape is parallel to the shape of the original object. In the first example, I am going to show you how to create parallel lines and curves as well as concentric circles with the offset command. The offset command can be found either in the Modify menu or in the Modify panel of the Home ribbon. Once it is active, the first thing I need to do is specify the offset distance. So I will type the number 30 and press Enter to move on to the next step. Next, I have to select the object I wish to offset, so I will click on the line. Then, a message appears which prompts me to specify the side which the parallel shape will be created. While moving the cursor, the preview changes accordingly. When I click on the side I want, the parallel line is being created, but the command does not deactivate. I can select the next shape I wish to offset, which is the curve, and click to create another parallel shape. Finally, I will click on the last shape of this example, which is the circle, and notice that the distance field is active in case I want to change the distance of the offset. Since I wish to create a concentric circle 40 units apart, I will move my cursor inside the existing circle to specify the side, type the number 40, and press Enter. Once I no longer wish to offset a shape, I will press Enter or Escape to deactivate the command. In the next example, I will show you the difference using offset on polylines and individual lines. The first shape is a polyline, so every linear segment is part of the same object. On the contrary, the second shape is not a polyline, they are three independent lines that create a similar shape. Let's see how creating a parallel shape of those two works. I will activate the offset command and set the distance to 35. Then I will move my cursor to the upper side of the polyline and click to create a parallel shape. Now I will proceed to do the same to the similar shape right below. However, this time I have to select each line separately, specify the offset side, and click to create the shape. In the end, the result is nowhere near the first shape, and that's to be expected since I created the parallel lines of three individual lines. The same thing happens with shapes like rectangles and polygons, which are by default polylines. When I use offset on a rectangle, as you can already see, a parallel rectangle is being created. Although, when I use offset command on lines, even if they form a rectangle, the result is not the same. Lastly, I would like to show you how you can easily draw a pipe corner with the offset tool. So, in the last example, I am going to recreate the pipe corner which can be seen on the left. I am going to activate the offset command and specify the distance as 20. Then, I will select the arc that represents the outer side of the pipe, move the cursor to the right, and click to create the arc that represents the inner side of the pipe. Next, I will select the same arc again, move the cursor to the right, and change the distance's value to 100. I will press Enter, select the same arc again, move the cursor to the right, and increase the distance to 120. I will press Enter twice to create the last arc and exit the command. As you can see, the pipe corner is finished. When we wish to distribute similar objects in a certain way, we can do it quickly if we use one of the AutoCAD's array tools. There are three types of arrays in AutoCAD: the rectangular array, the polar array, and the path array. All three arrays distribute object copies into any combination of rows, columns, and levels. In this lesson, we will learn how to create rectangular arrays. For this purpose, a drawing has been created in advance. As you can see, there is a stage and a single chair in the drawing. Let's say I wish to distribute 50 chairs like the one that has been placed. For this reason, I'm going to use the rectangular array command. The rectangular array can be found either in the Modify menu or in the Modify panel of the Home ribbon. Once the tool is active, I have to select the objects I want to distribute, so I will select the chair and press Enter. As soon as I pressed Enter, a preview of the rectangular array with 4 columns and 3 rows of chairs appeared. Furthermore, the Array Creation ribbon has appeared, containing all the necessary settings of the array. In the Columns panel, I can specify the number of chairs in each row and either the distance between them or the total distance the entire row will cover. I will change the value in the Columns field to 10 and the value in the Between field to 1. Notice that the value in the total field updated automatically. In this way, each row will have 10 chairs and the distance between the chairs will be 1. Next, I will move on to the Rows panel and I will increase the number of rows to 5. I will also set the total distance to 5, and notice that this time the value in the Between field updated automatically. So now there are 5 rows and the total distance from the first to the last row is 5. In the Levels field of the Levels panel, I am not going to change the value because I do not wish to create more levels. The levels appear in the XZ and YZ planes. Since I am working exclusively in the XY plane, I won't create many levels. So one level works just fine. Since there's only one level, the values in the distance fields don't matter. Lastly, there's a Properties panel with 2 buttons. With the associative feature active, all the chairs that are included in the array will be treated as one object. In addition, every time I will select the array, this contextual ribbon will appear. On the contrary, with the associative feature inactive, after I close the array, every chair will be an independent object and I won't be able to change the array's settings in the future. In this example, I will activate the associative option. The Base Point button redefines the base point of the array. By clicking on it, I can move the base point from the first chair of the first row to the middle of the stage. Now that I have finished editing the array, I will click on the Close Array button to create it. Notice that all 50 chairs are parts of the same object. As I mentioned before, when I select the array ribbon reappears. It's convenient that I can edit the rows, the columns, the levels, and even the base point whenever I need to. However, the associative button no longer appears. If, for some reason, I need to separate those objects after I have created the array, all I have to do is select the array, return to Home ribbon, and click on the Explode tool. As you can see, at the moment I can select and edit each chair individually, but I cannot edit them as an array anymore. In the previous lesson, we learned how to create rectangular arrays. In this lesson, we are going to learn how to create polar arrays. In the first example, there is a round table and a chair. Imagine I wish to distribute 8 chairs around the table. To do this easily, I'm going to use the polar array command. The polar array can be found either in the Modify menu or in the Modify panel of the Home ribbon. Once the tool is active, I have to select the objects I want to distribute, so I will select the chair and press Enter. Then I need to specify the center point of the array, which will be the center of the table. As soon as I clicked on the table center, a preview of the polar array with 6 chairs appeared.
In addition, as happens with every type of array, the array creation ribbon with all the necessary settings of the array appeared too. In the Items panel, I can specify the number of chairs in each row and either the angle between them or the total angle the chairs will fill. I will change the value in the Items field to 8, and the angle fields will update automatically. Since I wish the chairs to cover the entire perimeter of the table, I won't change any of those values. In the Rows and Levels panels, I will also not change anything, because in this example, I do not intend to create multiple rows or levels. In the end of this contextual ribbon, there is the Properties panel. The associative button defines if all the chairs that are included in the array will be treated as one object, and we will be able to continue editing them as an array in the future. In this example, I will not enable the associative option. The Base Point button redefines the base point of the array, and it works the same way it did in the rectangular array. Next, there is the Rotate Items button, which controls if the items will be rotated as they are arrayed. Notice that once I deactivate this option, the direction of the copies changes according to the direction of the original object. Since this is not what I want, I will enable the Rotate Items option again. As for the Direction button, it controls whether the direction of the array will be clockwise or counterclockwise, and we will understand how it works better in the next example. So at the moment, I have finished editing the array, and I am ready to click on the Close Array button to create it. Notice that 8 independent chairs have been distributed evenly around the table. Moving on to the next example, we see a hemispherical stage with a grand piano and a single chair. As you may have imagined, I wish to distribute 50 chairs around the stage, so at first I am going to select the Polar Array tool. Then I will select the objects I want to distribute and press Enter. Next, I will click on the center of the hemisphere to specify the center point of the array. As soon as I defined the center, a preview of the polar array with 6 chairs appeared. However, I don't want the chairs to cover 360 decimal degrees, so I will change the value in the fill field to 165. As you can see, the direction of the array is wrong. To change this, I will deactivate the Direction button. Notice that the chairs are now placed right. At this point, I will increase the number of chairs to 12 and the number of rows to 5. I will set the distance between the rows to 1 and reactivate the Associative button. Finally, I will close the array. Now, if I need to change it again, I just need to select it so the contextual ribbon reappears. In this lesson, we are going to learn how to create path arrays. As the name indicates, path arrays distribute items along a line or a curve. A drawing has been created in advance, and as you can see, there is a curve that represents the road, a street lamp, and a shrub. Let's say I wish to distribute 4 street lamps and 4 shrubs along the street. The most convenient way to achieve that is to use the Path Array tool. The Path Array can be found either in the Modify menu or in the Modify panel of the Home ribbon. Once the tool is active, I will select the objects I want to distribute, which in this case are the street lamp and the shrub, and I will press Enter. Next, I need to specify the path of the array, which will be the curve. As soon as I clicked on the curve, a preview of the array appeared. In addition, as happens with every type of array, the array creation ribbon with all the necessary settings of the array appeared too. Notice that in the Items panel, some fields are inactive. Before we specify the items and the distance, we need to define how to distribute items along the path. We have two options that can be found in the Properties panel. Those are Measure and Divide. Divide distributes items to divide evenly along the length of the path. As soon as the divide method is selected, the items field becomes active while the distance fields become both inactive. This means that I can specify the number of the objects that will be distributed, and the total distance as well as the distance between the objects are defined automatically. Measure, on the other hand, maintains the current spacing when the path or the number of items is edited through grips or the Properties palette. So when I select Measure, the Between field activates. If I click on the Items icon, I can activate the field, and along with the Item field, the Total field activates too. In this example, I am going to use the Divide method, and I will set the number of items to 4. In the Rows and Levels panels, I will not change anything because in this example I do not intend to create multiple rows or levels. In the end of this contextual ribbon, there's the Properties panel. As we have already mentioned, the associative button defines if all the objects of the array will be treated as one object, and we will be able to continue editing them as an array in the future. In this example, I will not enable the associative option. The Base Point button redefines the base point of the array, and it works the same way as it did in the rectangular and polar array. Next, there is the Tangent Direction button, which specifies the orientation of the first item relative to the path curve. The last important button is the Align Items button, which aligns each item to be tangent to the path direction. Notice that once I deactivate this option, the copies have the same orientation as the original objects, so the direction of the curve is being ignored. Since this is not what I want, I will enable the Align Items option again. So at the moment, I have finished editing the array and I'm ready to click on the Close Array button to create it. Notice that 8 independent objects have been distributed evenly on the curve. By now, you may have already noticed that when a command is in progress, several messages appear near the cursor, informing us about the actions that are required to complete the command. And while we are creating basic shapes such as lines, rectangles, circles, and so on, certain value fields appear so we can specify the length, the angle, the width, or the radius on the spot. Furthermore, if we move the cursor on the grips of a shape and wait a few seconds, its dimensions will appear. Even if we do not remember the full name of a command, we can insert its initial and immediately a list of suggestions from the AutoCAD command library is shown next to the cursor. All those conveniences are the result of dynamic input. So basically, dynamic input enables the tooltips command interface in the drawing area and provides an alternative way to insert a command, its value, and other subsequent changes to the command. Similar messages appear in the command line. The difference between the command line and dynamic input is that the dynamic input tooltips stay near the cursor. The dynamic input icon can be found in the status bar. In case it doesn't appear in your computer, you can click on the customization icon and select it from the contextual menu. When it's active, it is a lighter shade of blue. At this point, I will deactivate it and proceed to create a simple line. Notice that the command is active, but no message appears near the cursor. The message Specify Next Point appears only in the command line. Once I click to specify the start of the line, the value fields do not appear either.
However, I will move the cursor to the right and type the number 1000 to specify the direction and the length of the line. The number I just typed appears in the command line. I will press Enter twice and notice that if I select the line I just created and move the cursor on the right grip, the dimensions do not appear. Now it's time to move on to the next example to show you how I can modify the dimensions of a shape quickly when the dynamic input is turned on. So firstly, I will activate the dynamic input and select the first shape, which is the line. I will move the cursor on the right grip, and once the dimensions appear, I will click on the grip. Notice that a value field activates. Through this field, I can stretch the line. For example, I will type the number 200 and press Enter. The line is now stretched and its new length is 1200. If I click again on the grip and press Tab, the Lengths field activates and I can delete the current length and type the new one, which will be 1000. Once I press Enter, the line's length becomes 1000 again. Now I will click on the grip once more, and this time I will press Tab twice. In this way, the Angles field becomes active. The current angle is 25 decimal degrees. I will delete this number, type the number 60, and press Enter. The angle of the line changed accordingly. If I click on the middle grip, I can move the line in the drawing area. I will click again to move the line to a new position in the drawing area. Then I will press Escape and select the circle next to the line. By clicking on one of the 4 quadrant grips, the Radius field activates, so I can change the radius from 300 to 400. If I click on the center grip, I can move the circle around. I will reposition the circle, press Escape, and now I will select the ellipse. With the center grip, I can move the ellipse. If I click on the upper or the lower grip, I can change the length of the semi-minor axis, and if I click on the left or the right one, I can change the length of the semi-major axis. Last but not least, when it comes to rectangles and polygons, this way of changing the dimensions is not recommended. Notice that there is no center grip, so I cannot move polygons and rectangles in this way. Furthermore, if I click on one of the corner points, the length field becomes active. If I change the length from 800 to 600, the change is applied only on the side of the grip and the rectangle loses its shape. To make the length of both sides even again, I need to click on the other grip, press Tab until the lengths field is active, and change the value from 800 to 600. If I need to change the length or the width of a rectangle, it is a better idea to click on one of the grips in the middle of the sides. For example, I will click on the middle grip of the upper side and move the cursor up. Notice that the rectangle is being stretched. I can type the length of the extension, which is 200, and then I will press Enter. The rectangle has been stretched. Similarly, I could have reduced its length instead of increasing it. Polygons are even harder to modify in this way, so I would not recommend to modify polygons from the grips. While we are drawing, some shapes may overlap. To give you a clearer picture of what I mean, let's take a look at the open document. There's a house floor plan that includes quite a few objects in it, and even though you cannot tell at first glance, there are a few lines that overlap. To prove my point, I will select the outer wall by simply clicking on it. It seems all there is to it is a single polyline, But if I press Escape and use the window method to select again, notice that there is indeed a hidden line underneath. I will press Escape again and try to select this line. However, there is no way I can do that because this line is under the polyline. To be able to select it, I need to enable the selection cycling from the status bar. This icon does not appear in the status bar by default, so I will click on the customization icon and select it from the contextual menu. Once it appears, I will click on it to activate it. Like every other button in the status bar, when it's active, it becomes a lighter shade of blue. Now, if I move the cursor where one of the lines was, a symbol appears indicating that there are more than one object in this spot. Once I click to select, the selection dialog box appears with a list of all the objects that overlap. As you can see, there is a polyline and a line. When I move the cursor on an object from the list, the object is being highlighted in the drawing. In this way, I can see clearly what it is going to be selected and choose between the overlapping objects. Now I will click on the line and notice that it was selected easily. I will delete this line since I do not need it in the drawing. I can search all the lines that overlap and delete them one by one, but that will take a lot of time to achieve. Instead of searching the whole drawing, I can use a single command to remove all the duplicate objects at once. This command is called Delete Duplicate Objects and it can be found either in the Modify menu or in the Modify panel of the Home ribbon. Alternatively, we can just type the word overkill in the command line and press Enter. When the command is active, a message prompts me to select the objects. I will select the whole drawing and press Enter. Once I press Enter, the Delete Duplicate Objects dialog appears. The value in the tolerance field controls the precision with which overkill makes numeric comparisons. With Ignore Object property, some object properties can be ignored during comparison. In the Options section, there are several useful options. When Optimize segments within polylines is selected, individual line and arc segments within selected polylines are examined, and duplicate vertices and segments are removed. Within this option, there are two extra options. We can choose to ignore polyline segment width and to not allow polyline objects to be broken. Next, we can convert overlapping objects which either partially overlap or have common endpoints into single objects. Lastly, with Maintain Associative Objects selected, associative objects will not be deleted or modified. At this point, I will select OK without changing anything in this dialog. All the duplicate lines and arcs were effortlessly removed. Blocks are 2D objects that are included in AutoCAD libraries and can be found if we open the Design Center. Those objects are illustrations of several items such as furniture, electronics, plants, symbols, and many more. We can use them to add more detail in our drawings. As you can see, a simple floor plan has been created and some furniture blocks have already been inserted. Now we are going to add some more furniture in the empty room on the right. We can open the Design Center from the Tools menu if we move the cursor to Palettes, and from the available options, click on Design Center. Or we can go to the View tab in the Palettes panel and click on the Design Center icon. Alternatively, we can just type the phrase Design Center in the command line and press Enter.
Either way, the design center opens and we have to follow the right path in order to find all the available blocks. I suggest that you write down this path so it's easier for you to remember where to find them. Back to the design center, as you can see, there is a folder list on the left of the window. I will go up to the start of the list and notice that the first folder is Desktop. Under the Desktop folder, there is this PC folder with a plus icon next to it. I am going to click on this icon to expand the list which contains the subfolders. As you can see, the folder Local Disk appears with several subfolders of its own. From those, I am going to expand the Program File subfolder. From Program File subfolders, I will select to expand the Autodesk folder, and then I will move down until I find the subfolder of AutoCAD 20023, which is the version of AutoCAD I am currently using. Down to the list of AutoCAD 2023 subfolders, I will search and expand the Sample folder. From there, I will go to the English-US folder, and from the two subfolders it contains, I will expand the Design Center folder. Now we can see all the categories of blocks that have been installed along with the application. We can see the categories of blocks there too. I will double-click on the Home category and then double-click again on the Blocks icon. All the available blocks of this specific category appear, and I can insert any of them by clicking and dragging it in the drawing area. However, as you can see, the bed I just inserted that way needs further modification. Firstly, it needs to be moved to the right place. Secondly, it has to be rotated. And thirdly, I want to change its size. Of course, I can do those things after the insertion using the appropriate tools. However, I can also do those things before I insert the block in the drawing area. Instead of clicking and dragging the block, this time I will double-click on it. The dialog window Insert opens, and from there I can specify the insertion point, the scale, and also the rotation of the object. The insertion point defines the position where the block will be placed based on the coordinate system's origin. If the checkbox Specify on Screen is checked, as it is in the Insertion Point option right now, I am going to be asked to define this specific option after this dialog window closes. In this example, I will leave this checkbox active because I'm not going to define the position of the bed by specifying its coordinates. And most of the times, specifying the coordinates of a block's position is not so practical, so it's pretty common to leave this checkbox active. The scale defines the size of the object. Scaling an object proportionally means multiplying every linear dimension of it by the same factor. For instance, I could insert the bed double-sized by setting the values of the X, Y, and Z fields as 2. When I set the same value in all three fields, the size of the object increases or reduces proportionally in all three directions. However, I could scale the bed in one direction by changing the value of one field and leaving the rest set as 1. In case I want to scale the object proportionally, it's easier to do so if the Uniform Scale checkbox is active. Notice that now only the X field is active. When I change the value in this field, setting it as 1.2 for example, the other two fields update automatically. This means that the bed will be 1.2 times bigger than its original size. Rotation defines the angle at which the object is inserted. In this example, I will set the angle at 180 degrees. Last but not least, I want you to take a look at the Explode option in the lower left corner of the window. With this checkbox active, the bed will be inserted as a set of individual objects such as lines, rectangles, arcs, and so on.
If you want the block to be inserted as one single object, do not activate this checkbox. At this point, I will click OK and see what happens. Notice that the second bed I inserted is a little bigger than the first one, and the pillows are now in the opposite side. Furthermore, it is moving along with my cursor since its position has not been defined yet. If I want to move the upper side of the bed where the pillows are on the inner side of the window, I have to open the snaps list and check the nearest snap. This snap is represented by a symbol that resembles an hourglass and ensures me that the point of the bed that is gripped on the cursor will be placed on the line of the inner side of the window. So, with this snap active, I'm going to click on a random point on the inner side of the window to place the bed. As you can see, the bed now is placed. Since the design center is still open, I can continue inserting blocks. I can click on the back icon in the upper left corner twice and choose a different category to find another item I want. When I no longer need this window to appear, I will click the X symbol in the upper left corner and close it. Before we finish the lesson, I should mention that all blocks have an insertion point. So, if for example I need to move the first bed I inserted, I can select it, activate the Move command, and before specifying the base point, I will open the snaps list and enable the insertion snap. Then, I will move the cursor on the bed, and once the insertion snap symbol appears, I will click on it to define the base point. Lastly, I will move the bed to the other bedroom. In the previous lesson, we learned how to insert blocks from AutoCAD libraries. Although those libraries contain quite some categories with few blocks each, we still may not find the one we want. Of course, we can draw the item and copy it if needed, but that wouldn't make it a single object like a block. In addition, it wouldn't have the same properties that a block has. However, there are in fact two different ways to convert all the objects of a specific item into a single object. The first one is to convert those objects into a block which can be used only in the current drawing. The second one converts those objects into a block that is saved in our computer and enables us to use it repeatedly in any drawing we are working on. To understand this better, I have created a few items in this floor plan which are not blocks yet, but I am going to convert them into blocks right now. Let's say I'm an architect that has drawn the floor plans of the house you see. Even though I searched for a dining table accompanied by 4 chairs, I couldn't find one that was to my liking, so eventually I decided to draw my own dining set. I have placed it in the kitchen, but as you can see, it consists of several different and independent objects such as rectangles and lines. Firstly, I want to convert this dining set into a single object so I can modify it as one. Secondly, I may need to insert this block in the second floor too. However, I do not intend to use this dining set in future projects. Hence, I will go to the Insert ribbon and from the Block Definition panel, I will click on the arrow under the Create Block icon. As you can see, there are 2 available options there: the Create Block option and the Write Block option. Between the two, I will choose the Create Block option. The window block definition appears. In the name field, I will type the name My Dining Set. Then I have to specify the base point of the object. To specify the base point, I will click on the Pick Point icon and immediately the window disappears. Now all I have to do is zoom in on the dining set and make sure that the geometric center snap is active before I proceed any further. As we have mentioned before, the geometric center is basically the center of the mass of a 2-dimensional planar shape, and it works similarly to the circle center snap. I want to specify the base point on the center of the table, which is actually a rectangle. With the geometric center snap active, I will move the cursor on the perimeter of the table, and once its symbol appears, I will click on it. The block definition window reappears, and this time I have to select the objects which will be parts of the block. So I will click on the icon Select Objects, and once the window disappears again, I will make sure to select all the objects I need to create the block. I will press Enter to make the block definition window appear again. Under the Select Objects icon, I am given three options about the objects I have selected. I can create the block yet retain the objects as they are by choosing Retain. I can create the block and at the same time convert the selected objects into a block too by choosing Convert to Block. Or I can create the block but delete the selected objects by choosing Delete. Since I want to convert the selected objects into a block, I won't change the default option. Under these three options, we can see the total number of the selected items. In this example, I selected 21 objects. In the lower part of the window and the Settings option, I can define the units of the block. Typically, we want the units of the blocks to coincide with the units of the drawing, so I will set mirrors in this field. In case we want to write a description about this block, we can do it in the description field on the right. When everything is set, I will click OK to finish the block's creation. Now every time I select the dining set, the table is selected along with the chairs since they are all parts of the same block. If I want to insert this block again, I can do it from the Insert ribbon and the panel block by clicking the Insert button. The same button is also in the Home ribbon. I will click on the Insert button, and if I do not see the block I created on the list, I can choose to open Recent Blocks. In the lower right corner, the Blocks palette appears. From the Recent Blocks tab, I can drag and drop another dining set on the second floor. However, remember that this block is not available in other drawings. To prove my point, I will create a new drawing. Notice that in the Recent Blocks tab, my dining set is not available anymore. It has been removed from the list, but I don't mind because, as I mentioned before, I do not plan on using it in another project. However, there is a symbol that an architect uses quite regularly, and this symbol is the symbol that shows the height of an area from zero level. At this point, I will close the Blocks palette and return to the drawing I was working with. You can see that symbol in the bedroom of the first floor. This symbol and this number indicate that the bedroom is 25 centimeters above the zero level. When I select the symbol, as you can see, it consists of several different objects. I will convert this symbol into a block, but since I want it to be available in future projects too, I'm going to use a different method. I will go to the Insert ribbon, and from the Block Definition panel, I will click on the arrow under the Create Block icon again. This time, I will select the Right Block option. The window Right Block appears, and it is quite similar to the Block Definition window which we previously saw. In the Source field, I will select Objects since I am going to create a new block using some of the objects of the current drawing. Like I did in the previous example of creating a block, I have to specify the base point of the object. So I will click on the Pick Point icon, and once the window disappears, I will zoom in on the symbol. Before I proceed any further, I will make sure that the center snap is active. I will specify the base point on the center of the circle. The right block window reappears, and this time I have to select the objects of the block.
So I will click on the icon Select Objects, and once the window disappears again, I will make sure to select all the objects of the symbol apart from the number. I will press Enter to make the right block window appear again. Under the Select Objects icon, there are the same three options I also had when I created a block previously. I will create the block, and at the same time I will convert the selected objects into a block by choosing Convert to Block. This time the selected objects are 4. From the destination options, I can define the path where the block will be saved and its units. In the File Name and Path field, I can see in which folder of my computer the block is going to be saved. I can change the location by clicking on the 3 dots next to the path. For this example, I will choose the desktop folder, and in the File's Name field, I will type the word symbol. Then I will click on Save. As for the units, we usually want them to coincide with the units of the rest of the drawing, so I will set meters in this field. Once everything is set, I will click OK, and the new block has been created and saved in my computer for further use. Now, if I move my cursor on this symbol, it is highlighted as one object. When I need to insert the symbol again, I will click on the Insert button from the block panel. Then I will select Blocks from Libraries and find the file in the folder I saved it. I will select it and click Open. The Blocks palette opens again, only this time the Libraries tab is active. I can drag and drop the symbol in the garden and anywhere else in this drawing. I can load this block anytime in any drawing from the folder that was saved. While we are working on a project, it's highly recommended that we organize the items of our drawing in groups according to the category they fall into. In AutoCAD, those groups are called layers. In order to manage layers, we have to open the Layer Properties palette. We can open this palette either from the Format menu or from the Layers panel of the Home ribbon by clicking the Layer Properties button. Once it's open, there is a list with all the existing layers. Every time we create a new drawing, there is one layer by default, and this is the 0 layer. Sometimes you may notice another layer which is called Definition Points. The Definition Points layer is a standard system layer that is automatically generated when a dimension is created in the drawing. The objects on this layer are visible in the drawing area but will not appear when we plot our drawing. So it's not a good practice to use this layer while drawing. In the current drawing, some dimensions have already been created, so as you can see, this layer is already in the list. Apparently, 4 more layers have been created: Walls, Windows and Doors, Dimensions, and Layer 1. To create a new layer, I will click on the New Layer button. I will type the word Furniture and press Enter to define the name. I should mention that if I right-click on a layer, I can rename it or even delete it. For example, I will select Layer 1, right-click on it, and then select the Delete option. Alternatively, I could have clicked on the Delete Layer icon. As long as the layer doesn't contain objects, it will be deleted. In the same way, I could change the name of the selected layer by clicking on the Rename option. However, note that you cannot delete or rename the default layers, which are the 0 layer and the Definition Points layer. In the current example, every part of the walls has been inserted in the Walls layer, while all the doors and windows have been moved in the Windows and Doors layer. In addition, the dimensions have been moved in the Dimensions layer too. In the layer list, next to the layer's name, there are some icons. The first one, which is depicted by a light bulb, turns on and off the selected layer. When this icon is yellow, it means that the layer is on. Consequently, its objects are visible and available for plotting. On the contrary, if I click on it, the layer turns off and its objects are no longer visible nor can be plotted. I will hide the walls layer and notice how the walls were hidden from the drawing. Now we'll click again to turn the walls layer back on. If I click on the second icon, which looks like a sun, it becomes a snowflake and the layer freezes. This means that the objects of the frozen layer are not displayed, plotted, or regenerated. Notice that once I freeze the walls layer, the walls are no longer visible even though the layer is turned on. You can freeze the layers to improve performance and reduce the regeneration time in complex drawings. At this point, I will unfreeze the walls layer. Next to the freeze icon, there is a padlock icon. When the padlock is locked, the objects of the layer cannot be modified. I will lock the walls layer so I will not accidentally move them while drawing. The printer icon controls whether the selected layers will be plotted or not. If I turn off the plotting for a layer, the objects on that layer are still visible, but they will not be printed. Note that layers that are turned off or frozen are not plotted regardless of the plot setting. Next to those options, there are a few properties that can be changed, such as the color of the objects that are included in the layer, the line type, the line weight, and the transparency. In this example, I will change the color of furniture layer to brown and the color of the dimensions layer to gray. Then I will change the line weight of the walls to 0.30 millimeters. Notice that the width of the walls changed and the dimensions are now gray. As for the furniture's color, it didn't change, but this was to be expected since no objects have been moved to the furniture layer yet. The last thing I should mention is that the layer that has a check mark in the left of its name is the current layer, which means that everything that I'm going to draw from now on will be included in this layer. To change the current layer, I have to double-click on the name of the layer I wish to make current, or select it and click on the Set Current icon. Alternatively, I can right-click on the layer and select the Set Current option. In this example, I will select the Dimensions layer and I will click on the Set Current icon. Then I will close the Properties palette, which I no longer need, and proceed to move its objects in the appropriate layer. If you take a look in the Layers panel of the Home ribbon, the current layer is shown when no object is selected. If I select an object, let's say the bed for example, the layer which the bed belongs to appears in the panel. At the moment, the bed, as well as the rest of the furniture, belong to the 0 layer. To change that, I will select all the furniture first, and when I carefully make sure that I have selected them all, I will open the list and select the furniture layer. I will press Escape to unselect everything, and notice that now it's obvious that the furniture changed color according to the layer I moved them to. Lastly, I will create the bedroom's door which is missing. First and foremost, I will press Escape to unselect all the objects, and then I will proceed to change the current layer to Windows and Doors. This time, instead of opening the Layers palette, I will just open the list from the Layers panel and select the Windows and Doors layer. That was another way to change the current layer. At this point, I will select the office's door and frame, and then I will activate the Copy tool. I will specify the base point on the right corner of the door's frame, and then I will click on the right upper corner of the bedroom's wall to copy it. I will press Escape to exit the copy command. Notice that this door was also created in the Windows and Doors layer. So, to sum up, by separating the objects in different layers, we can change certain properties of the objects by changing the properties of the layer they belong to. Furthermore, it is easier to manage the objects of the same layer at once. Before we finish the lesson, I should mention that it's more convenient to create the layers in the beginning and draw the objects directly in the right layer than changing the layer of each object later. Apart from changing the properties of the objects through layers, we can also change the properties of an object individually. In the following drawing, the section of a mechanical component has been created in advance. As you can see, the necessary dimensions have also been created. Since this drawing is representing the section of an object, a hatch has also been inserted. In this lesson, we will see how we can change the properties of some certain objects as we see fit. Firstly, I will change the color of the dimensions. To select all the dimensions easily, I am going to hide all the other layers except the Dimensions layer. To do that, I will open the Layers list from the Layer panel of the Home ribbon and click on the light bulb of each layer. Once I click on the light bulb icon of the zero layer, a message appears to inform me that the current layer will be turned off. In this case, I do not mind because I do not intend to draw anything, so I will click on the Turn the current layer off option. Now that only the dimensions are visible, I will select them all using the Window method. Then, I will expand the first list in the Properties panel of the Home ribbon, which has to do with the object's color, and select a light blue color. I will press Escape and notice that the color has changed. At this point, I will turn on the zero layer in which the main object was created, and I will also turn off the Dimensions layer. This time, I will increase the width of the object's lines, so I will select them all with the Window method. Next, I will expand the second list in the Properties panel of the Home ribbon, which represents the line weight, and select the 0.30 mm option. I will press Escape to unselect everything, but notice that nothing seems to have changed. The reason this happened is because the default setting in AutoCAD is to not show the line weights. To change that, I will click on the customization icon in the lower right corner and check the line weight option. The icon now appears in the status bar, but it is not active. Once I click on it, it becomes a lighter shade of blue, which means that it's active. Notice that now the line weight is visible. At this point, I will turn on the Center Lines layer. The lines that indicate the center of the circles are shown, however they are just continuous lines and not centered lines as they should be. To fix that, I need to change the line type of these lines. Before I select anything, I will expand the third list in the Properties panel of the Home ribbon to see if the line type I want is loaded in the drawing. As you can see, the only type of line that is available in the list is the continuous line. That means that I have to load a center line in the drawing, hence I will click on the other option. The Line Type Manager window with all the loaded line types appears. I will click on the Load button, and from the new window that appears, I will search for the center line type. Once I find it, I will select it and click OK. Now, the center line is added to the list of the Line Type Manager window. I will click OK to close this window too, and now I will carefully select the lines I wish to be center lines. I will expand the third list in the Properties panel of the Home ribbon again, and I will select the center type.
Even though the line type changed, notice that no change is visible in the drawing. The line type scale is to blame for this result. So I need to select them again. Once I have selected them, I will right-click somewhere in the drawing area, and from the menu that appears, I will select the Properties option. In this way, the Properties palette opens. In this palette, we can find and modify several interesting properties of the selected objects. However, in this lesson, we won't elaborate on all the properties that are included in this palette. The only one that I'm interested in at the moment is the line type scale, which is currently set to 1. I will change the value of this field to 0.25 and press Enter. Notice that the center lines changed and their pattern is now visible. I should mention that sometimes you may have to experiment quite a bit before you find the appropriate scale value. At this point, I will close the Properties palette, and while those lines are still selected, I will expand the Properties panel. As you can see, I can also add transparency to the selected objects. In the Value field next to the word Transparency, I will type the number 50 and I will press Enter. Then I will press Escape to see the result clearly. Before we finish the lesson, I will show you how we can match the properties of two objects. To get a clearer picture of what I mean, let's say I want the two lines of the rectangle to have the same properties as the lines that indicate the circle centers. Instead of selecting them and change their type and the transparency value, I will click on the Match Properties button, which can be found in the Properties panel of the Home ribbon. As soon as the tool is active, a message prompts me to select the source objects whose properties I wish to copy. So I will select one of the center lines. Then I have to select the destination objects, namely, the objects I wish to have the same properties with the source object. I will click on the vertical line first, and then on the horizontal one. Notice that their appearance changed automatically. Once I'm done, I will press Escape to deactivate the command. Finally, I will turn back on all the layers that I hid to see the final result of the drawing. It's important to mention that by changing those properties, we override the properties we have set in layers. In the previous lesson, we learned how to change certain properties of objects, such as their color, their line type, their line weight, and the transparency. All those properties, along with more features, can be found in the Properties palette. Firstly, I have to select an object from the drawing. In this example, I will select the rectangle. Then, I will right-click and from the menu that appears, I will select the Properties option. The Properties palette appears automatically. I will click on the right side of the palette and drag it to the left until it's docked to the side of the application window. Now I can study the contents of the palette. In the upper side of the palette appears the type of the object that is currently selected. As you can see, the rectangle is considered a polyline. In General Properties, we can identify general features of the object, such as the color, the line type scale, the line weight, and the layer the object belongs to, among others. We can change any of these properties by either expanding the list with the available options or by entering a new value in the desired field. For instance, I will expand the layer list and I will select the 0 layer. Notice that the rectangle belongs now to the 0 layer instead of the center lines layer. Another interesting thing is that in the geometry properties we can find the area and the length of the object, which is quite useful in closed profiles. Now I will press Escape to unselect the rectangle. When no objects are selected, only the current settings of general properties are displayed.
If I select one of the circles, apart from the general properties, I can also find the coordinates of its center, its radius and diameter, as well as the perimeter and the area of the circle. Naturally, I can change any of those from this palette. For example, I will change the diameter from 26 to 22. So I will type the number 22 and press Enter. The diameter changed automatically. I will click on the Undo icon from the Quick Access toolbar to reset the circle's diameter, and at this point I will select the hatch. This time there are the general properties that do not differ from the other object's properties, and the hatch's properties which have to do with the pattern of the hatch. I will change the scale to 2, and the difference is visible. Before we finish the lesson, I should mention that if more than one objects are selected, only their common properties are displayed. To get a better idea of what I mean, I will select 3 circles. Notice that in almost all the geometry fields the word varies appears, which means that those values are different for each circle. Now if I add the hatch to the selection, notice that the properties that appear in the palette are even less and most of their values vary. In previous lessons, we learned how to create center lines from the scratch. However, AutoCAD provides the appropriate tools for inserting center lines automatically in both circles and lines. I will activate the Annotate ribbon and take a look at the third panel, which is the Center Lines panel. The first tool is called Center Mark, and it applies to circles and arcs. I will activate the tool and click on the first circle. Notice that the tool does not deactivate automatically, and I can keep placing center marks to the circles. Once I have placed a center mark in each circle, I will press Escape to deactivate the command. Next, I will activate the Center Line tool, which can be found next to the Center Mark tool. This command requires to select 2 lines, so I will click on the left vertical of the rectangle and then on the right vertical, and notice that the center line appeared automatically. This command, though, deactivates as soon as the center line is created. So I will press Enter to reactivate the Center Line tool again, and this time I will select the upper horizontal side of the rectangle and then the lower side. The tool deactivated automatically, and now all I have to do is to adjust the scale of these lines and marks. So, at this point, I will select the 2 center lines and right-click to open the Properties palette. Notice that the line type is indeed center, but that is not visible in the model. To correct that, I will change the line type scale to 0.5. Notice that now the pattern looks better. Now we'll press Escape, and without closing the Properties palette, I will select all the center marks that I have placed in the circles. In the Geometry properties, we can find a variety of settings for those center marks. I will change the extension of every side to 2, and then I will press Escape to see the result. Now the edges of the center marks do not intersect, and they are clearly visible. Similarly, I could have changed the start and end extensions of the center lines. While we are drawing, we may need to check if the dimensions we specified are correct. To get a quick view of the dimensions within my drawing, I can click on the arrow of the Measure tool, which can be found in the Home ribbon, and activate the Quick Measure tool. Notice that this tool displays the dimensions, distances, and angles dynamically as I move my cursor over and between objects. I will press Escape to deactivate the tool,
and reopen the list with the measuring options to show you the next one, which is the distance option. I can measure the length of a line by clicking on the first endpoint and then on the other. In this example, the length of the line I measured is 5.2. Notice that the tool does not deactivate. On the contrary, a list with all the measuring options appears, so I can continue measuring. I will select the distance option again, and I will proceed to measure the distance between the middle chair and the sofa. Once I am sure that those distances are correct, I will select the radius option and click on the inner wall's polyline arc. Automatically, the radius and diameter of the arc are being displayed. Naturally, with this option, I can also measure the radius and diameter of a circle or an arc. At this point, I am going to select the angle option and I will click on the sloped side of the slab and then on the horizontal side. The angle between the two lines is 120 degrees. I can either select the next option or press Escape to deactivate the measuring tool. I should mention that all these options we previously selected from the list can be found in the list of the Measure button too. I will select the Area option to measure the area of the kitchen, the living room, and the office. To measure the area, I need to trace the perimeter of the object or the room whose area I wish to measure. I will start by clicking on the lower right endpoint of the kitchen's wall, and then I will click on the lower left endpoint. Next, I will click on the endpoint right before the arc. At this point, I have to click on the arc option in the command line in order to be able to trace the arc of the wall. So I will select the arc option, and then I will click on the other endpoint of the arc. Now, as you can see, I have to return to the line option again before I continue tracing, so I will click on the line option from the command line. I will click on the rest of the endpoints until I reach the first point I clicked. Once I am done tracing the perimeter of the area, I will press Enter and both the area and the perimeter are being displayed. But what happens if I wish to measure the area of two rooms that are not next to each other? Let's say I wish to measure the area of the bathroom and the office. In this case, I will select the Area option from the list, and before I start defining the corner points, I will select the Add Area option from the command line. I will define the corner points of the bathroom's perimeter and press Enter. Although the bathroom's area and perimeter are being displayed, I can still add areas. So I will also trace the perimeter of the office. Once I press Enter again, notice that below the office's area and perimeter, the total area is displayed. Now, imagine that I wish to measure the area of the kitchen and the living room, and then I want to remove the area of the kitchen. To do that, I will press Enter one more time so the list with all the measuring options will appear again. I will select the Area option once more. If I intend to subtract areas, I have to select the Add Area option before I start measuring. Now all I need to do is trace the perimeter of those two rooms, and once I'm done with specifying carefully all the corner points, I will press Enter. Then I will select the Subtract Area option from the command line and I will trace the kitchen's perimeter. I will start by clicking on the lower left corner, then on the lower right corner, and then on the upper right corner. Once I reach the left side, I will use the perpendicular snap to define the last corner. I will press Enter, and now the area and the perimeter of the subtracted area, namely the kitchen, appear first. The total area of the two rooms also appears below. Last but not least, I will show you how you can calculate the volume of an object. I will press Enter one more time to select the volume option. In this example, I will calculate the volume of the wardrobe in the bedroom. To calculate the volume, I need to trace the perimeter of the object. Alternatively, I can select the object option from the command line and select the polyline that represents the wardrobe. Once I select the object, I have to specify the height of the object. I will type the number 1.76 and then press Enter. The volume was calculated and it is about 5.45 cubic meters. When I no longer wish to measure anything else, I can press Escape or select the Exit option to deactivate the command. There will be quite a few times that we will need to insert annotations in our drawings. The first thing that we will learn is how to create texts. In the open drawing, we see the floor plan of a house's first floor. Let's say that I wish to write underneath the floor plan the words first floor. To do that, I'm going to use the text tool. The text tools can be found in the Annotation panel of the Home ribbon. When I click on the arrow under the text icon, two options appear, the multi-line text and the single-line text. With the single-line tool, we specify the height and the orientation of the text before we start typing, and after that, we can only edit the text content. On the contrary, the multi-line text tool provides more edit options for the appearance of the text, not to mention that, as its name indicates, it can create multiple rows too. So between the two, I am going to choose the multi-line text for obvious reasons. The first thing I should do once the command is active is to click somewhere in the drawing area to specify the first corner of the text frame. So I will hover the cursor on the lower left endpoint of the wall, and once the reference line appears, I will move down on it and click to specify the first corner. Next, I have to click to specify the opposite corner. So I will move the cursor lower on the right and click again. This is exactly how I would create a rectangle. The second time I click, the text frame appears, and so does the text editor ribbon. I will type the phrase first floor. As you can see, the letters S and T are not in superscript. In addition, the letters are too big and they cover 2 rows instead of 1. To correct all those, I will start by clicking and dragging the rhombus symbol above the text to the right. Next, to reduce the size of the letters, I will select the whole text and move to the Style panel of the contextual ribbon. It's really important to select the text before you make changes, otherwise none of them will be applied. So with the text selected, I will change the value in the size field from 2.5 to 0.4. Once I press Enter, the size changes accordingly. I will click on the rhombus symbol and drag to the right to adjust the frame again. From the Formatting panel, I can change the appearance of the text. For example, I can change the letters' font, the color, the layer they belong to, and I can also make them bold, italic, underlined, and so on. At this point, I will make the letters italic, change the font to Calibri, the color to gray, and set the layer in which the text will belong to the 0 layer. I will click inside the text box to unselect the text and get a better picture of the changes I made. Now, all I have to do is select the letters S and T and make them superscript. From the Paragraph panel, I can change the justification of the text. Once I am done editing the text, I will click on Close Text Editor. The text item is finished, yet I can edit it again easily if I just double-click on it. The contextual ribbon reappeared, and I can change the format or the content of the text. At this point, I want you to see the symbol that there is in the garden. The symbol shows the height of an area from zero level, but in this one the height is missing. To add the height, I will activate the multi-line text again and create a text box above the symbol's horizontal line. I will click on the symbol icon in the Insert panel, and I will select the +/- from the list. Then I will type the number 0.0, select what I just typed, and change the font size to 0.15. Before I close the text editor, I should mention that in case the symbol you are searching for is not in the list, you can click on the other option. From the symbol window that appears, you can search the symbol you want. Once you find it, click on it, then click on Select, and finally on the Copy button. At that point, you can close the Symbols dialog window, right-click in the text box, and paste the symbol you just copied. Now I will close the text editor and I will select the text item. Then I will right-click on it and select the Move option from the menu. I will open the Snaps list, activate the Insertion Snap, and then close the list. Apart from blocks, the Insertion Snap applies to texts too. I will specify the base point on the insertion snap of the text and move it above the horizontal line of the symbol. Once we finish drawing, it is highly possible that we will want to insert dimensions. There are different types of dimensions that can be found either in the Dimension menu or in the Annotation panel of the Home ribbon. To see when we use each type of dimension, a few simple shapes have been created in advance. At first, I will select the linear dimension, which creates horizontal and vertical dimensions. A message prompts me to select the first extension line origin point, which in this example is the end point of the triangle's horizontal side. Once I click on it, another message prompts me to select the second extension line origin point, which is the other end point of the same side. Now, as I move the cursor up and down, the dimension moves along. I can place the dimension either above or below the line, so I will move the cursor below and click to finally place the dimension. Once I place the linear dimension, the tool deactivates automatically. Same goes for all the dimension options in the list. Now we'll press Enter to reactivate the linear dimension command, and I will repeat the procedure to insert a vertical dimension to the vertical side too. Notice that I can place the dimension either on the left or on the right side. This time I will place it on the right side. When it comes to inclined lines, such as the hypotenuse in the current example, the linear dimension will not display the length of the side, but the linear distance between the endpoints of the side. So, to display the actual length of this side, I will open the list with the dimension options and select the aligned dimension. Again, I have to select the first extension line origin point, which will be the first endpoint of the line, and then the second extension line origin point, which will be the other endpoint of the line. The length of the side appeared, and notice that the extension lines are parallel to the hypotenuse. I will click to place this dimension too, and move on to insert dimensions to the angles. From the available options, I will select the Angular option, which measures the angle between selected geometric objects or 3 points. I will select the vertical side first, and then the hypotenuse. Notice that this angle is 35 decimal degrees. I will click again to place the angular dimension, and then I will press Enter to reactivate the angular dimension command. I will repeat the procedure for the second acute angle, selecting the horizontal side first, and then I will select the hypotenuse. Next, I will click to place the dimension. It's time to move on to the next shape to insert some more dimensions. The next option in the list is the arc length option. I can specify the distance along an arc or a polyline arc segment with this dimension. I will select it and proceed to measure the length of the fillet in the upper left corner of the shape. All I need to do is select the arc or the polyline, so I will click on the arc segment of the shape's perimeter. The dimension appears automatically, and I can place it where I think that it looks better by clicking once more. There are another two dimension options that apply to arcs, the radius option and the diameter option. Naturally, apart from arcs, those dimensions apply to circles too. The radius option measures the radius of a selected circle or arc and displays the dimension text with the radius symbol in front of it. On the other hand, the diameter option measures the diameter of a selected circle or arc and displays the dimension text with the diameter symbol in front of it. I will select the radius option first, and then I will click on the big circle. Once I clicked on it, the radius appeared and I have to decide the direction which I will place it. I will move the cursor around to experiment a bit and finally click to place the dimension inside the circle. Then I will open the list again and select the diameter option. I will select the smaller circle and click to place the diameter dimension outside of this circle. Before I move to the next option, I should mention that I can measure the chamfers distances using the linear dimension option. So I will select the linear dimension and click on the endpoints of the sloped angle. Notice that if I move the cursor up, the horizontal distance appears, and if I move the cursor to the right, the vertical distance appears. I will place the horizontal distance first, and then I will repeat the procedure to place the vertical one too. The last option that I will show you from the list is the ordinate option, which measures the horizontal or vertical distance from the AutoCAD's origin point. I will click on the point that has been placed, move upwards, and click to place the distance of the point from the x-axis. Then, I will reactivate the ordinate dimension, move the cursor to the right, and click to place the distance of the point from the y-axis. In case you were confused about why the horizontal distance of the point appears vertically and the vertical distance appears horizontally, the following graph will help you get a clearer idea of this dimension option. Before we finish the lesson, I should mention another two useful dimension options that are not included in the list. Those two options are the continue and the baseline dimensions, which can be found either in the dimension menu or in the Annotate ribbon in the Dimensions panel. The continue dimension creates a dimension that starts from an extension line of the previous or selected dimension. So firstly, before I select the continue dimension, I will place a linear dimension to the first linear segment of the next shape. When I do that, I will activate the continue dimension and notice that it starts automatically from the extension line of the linear dimension that I previously created. I will click on the end point of the next linear segment to place the next dimension and notice that contrary to all the previous ones, this dimension option does not deactivate automatically. I can keep clicking on the rest endpoints to place the rest dimensions. In case I accidentally click on the wrong point, I can undo the last continuous dimension by clicking the Undo option from the command line. Once I place all the dimensions I want, I will press Escape to deactivate the tool manually. Last but not least is the baseline dimension, which creates a linear, angular, or ordinate dimension from the baseline of the previous or selected dimension. As you can see, a linear dimension has already been placed in the next example, so I will activate the baseline dimension and select the left extension line of this dimension. Notice that now, as I move the cursor to the right, the total distance appears. I will click on the end point of the next linear segment, and the dimension is being placed above the first one. Furthermore, it shows the total distance from the left end point of the first linear segment. This dimension option does not deactivate automatically either. In case I accidentally click on the wrong spot, I can select Undo from the command line. When I no longer need the tool, I will press Escape to deactivate it. In the previous lesson, we learned how to insert several dimensions. However, depending on the size of our drawing and our own preferences, we may need to modify the dimension style. For example, in the current drawing, as you can see, the dimensions do not appear correctly. In fact, I have to zoom in a lot to even see if there really are dimensions. So, in this case, I definitely need to change the way the dimensions appear. To modify the dimension styles, I need to open the Dimension Style Manager window. I can open this window if I expand either the Format menu or the Dimension menu. Alternatively, I can expand the Annotation panel of the Home ribbon and click on the Dimension Style icon. Once I click on it, the window with all the available dimension styles appears. Since in this drawing the AutoCAD ISO template was selected, there is also the ISO 25 dimension style. Before I proceed to change anything, I should mention that the style that was used in this drawing is the standard style. So I will select the standard style and click on the Modify button. A new window opens with several tabs that contain all the available modification options. Firstly, I will open the Primary Units tab to change the precision of the dimensions to 0 decimal places. So I will open the list of the Linear Dimensions Precision field and select the first option. Notice that the preview on the right changed accordingly. Similarly, I can change the precision of the angular dimensions from the list in the Angular Dimension section. I will set the number of decimal places to 1 for angles. Next, to adjust the text size, I will move to the Text tab and change the value in the Text Height field to 5. From the Text Appearance section, I can change the way the text appears. I will click on the text color list and apply the cyan color to the text. Right now, from the Fill Color text, I can set a color for the background. Notice how the preview changes when I select a color for the background. However, in this example, I will reopen the list and select the None option to remove the background color again. By activating the checkbox of Draw Frame Around Text option, an outline is created around the numbers. I will deactivate this option again and move to the Text Placement options. Vertically, we usually select either the Centered option or the Above option. In this case, I will select the Centered option, so the numbers will appear in the center of the dimension line. I am also given quite a few options about the horizontal text placement, but in the end, the Centered option is what is mostly used. The View Direction field controls the direction of the text, and in my case, I do not need to change the default option. An important field is the Offset from the Dimension Line field. The value in this field defines the gap between the text and the dimension line. As you can see, the current value is 0.09. If we look at the preview, the dimension lines are too close to the numbers. To get a clearer picture of what this number represents, I will change the offset value to 5. Now if you look at the preview again, notice that there is a big difference in how the dimension lines appear. The value I set is a bit exaggerated relatively to the size of the numbers, but as I mentioned earlier, I wanted to give you a clearer picture of what this offset value represents. So I will change this value again to 1.5. Finally, I can align the text with the dimension line. To understand what changes, I suggest that you look at the vertical and the align dimensions in the preview. Even though I have finished with the changes I wanted to make concerning the way the text appears, it seems that the arrows have disappeared. I will go to the Symbols and Arrows tab and notice that the arrow size is 0.18, which is way smaller than the size of the numbers, which was set to 5, and that's why they aren't visible in the preview. So, first and foremost, I will change the arrow size to a number close to the text size. In this example, I will set this value to 4.5 and notice how the arrows reappear in the preview. From the drop-down lists above the arrow size field, I can change the arrowhead type of dimension lines. At the moment, I will select the dot type. Next, I can define how the center marks will appear. If I check None, then no center mark appears in the circle. By activating the Mark option, a center mark appears, but again, compared to the text and arrows, it's too small to be clearly visible. So I will type the number 2 in the value field next to the Mark option, and notice how it appears in the preview. By selecting the Line option, lines appear in the center of the circle. In this example, I will select the None option and move on to the Arc Length symbol options to define how the arc symbol will appear. Since there is no arc length dimension in the preview, I will explain the 3 options using an image. If I select the first option, the symbol will appear before the number. If I select the second option, the symbol will appear above the number. And if I select None, then the arc symbol will not appear at all. In this example, I will select the Above Dimension Text option. Last but not least, I will modify the dimension and the extension lines. To do that, I will activate the first tab. The first section has to do with the dimension lines, while the second with the extension lines. In the first section, I will change the color of the dimension lines to cyan. I can also change the line type as well as the line weight if needed. In this example, though, I will not change those options. Extend Beyond Ticks becomes available if you select the architectural, the oblique, or the integral arrow type. It defines the distance of the dimensions line extension beyond the extension lines as shown in the image. The value of baseline spacing sets the spacing between the dimension lines of baseline dimensions. Since I set the text size to 4, I will change the baseline spacing to 12. Moving on, if I select to suppress the dimension lines by activating the checkboxes Dimension Line 1 and Dimension Line 2, as you can see in the preview, they disappear completely. I will not suppress the dimension lines since this is not what I want to do, and I will move on to the extension lines options. The first option defines the color of the extension lines, which I will also change to cyan. Just like in dimension lines, I can also change the line type as well as the line weight if needed. Furthermore, I can suppress the extension lines if I do not wish them to appear. In case I do not suppress them, I can specify the length of the extension beyond the dimension lines and the gap between the extension lines and the points that define the dimension. In this example, I will set the value in the Extend Beyond Dimension Lines field to 5, and in the Offset from Origin field, I will set the value to 1. If I wish them to have a fixed length, I can activate the checkbox of the Fixed Length Extension Lines option. Once I am satisfied with the result, I will click OK to exit the Modify Dimension Style window, and I will also close the Dimension Style Manager window. Notice how different the dimensions appear, and most importantly, how clearer we can see them compared to previously. Now the first shape is the section of a pipe corner, and the dimension in the middle represents the diameter. However, since in this particular view of the pipe there is no circle or arc, the aligned dimension was used to display the distance of the diameter. In case I want to add the symbol of the diameter before the number of the distance, I will double-click on it. Once I double-click on it, the text editor ribbon appears and I can edit the text. So from the Insert panel and the Symbols drop-down, I will select the diameter symbol. Then I will click on Close Text Editor and repeat the procedure for the other two aligned dimensions that represent diameters. Now I will inspect the second shape. Notice that the baseline dimensions are still on one another, even though I have already increased the baseline spacing significantly. Unfortunately, I have to delete the baseline dimensions and reinsert them in order to be placed with the new distance I specified earlier. So I will select those dimensions and delete them. Then I will open the Dimension menu and select the Baseline option. I will click on the left exit line of the linear dimension that remained, and then I will click on the end points to insert the baseline dimensions. Once I'm done, I will press Escape to exit the command. Apart from the dimensions and texts, we can also insert leaders to explain what each part of our drawing indicates. In this example, the 2D views of the parts of a pulley support have been created. To get a better picture of the objects that are depicted in the views, an image of the 3D object is shown. These are all parts of a pulley support. If we assemble those parts, a pulley support is being created. Back to the drawing, I will insert leaders with the name of each part as was shown in the image. To insert a leader, I can open the Dimension menu and select the Multi-Leader option. Or I can go to the Home ribbon and select the leader option from the Annotation panel. The first part is the pulley. I have to specify the leader arrowhead location first, so I will open the nearest object snap, and then I will click somewhere on the front view of the pulley to place the arrow. Next, I will specify the leader line by clicking on the left. In the last step, I have to specify the leader's content, so I will type the word pulley. Notice that the text editor ribbon appeared, so I can modify the text if I need to. Once I make the changes I want, I will click on the Close Text Editor button to finish the leader's creation. Then I will reactivate the leader tool and proceed to insert the second leader to the next part, which is the bushing. I will click on the external circle of the front view to place the arrow, then click to specify the leader line, And finally, I will type the word bushing and close the text editor to insert this leader too. I will continue inserting leaders to the rest of the parts in the same way. The last two parts are both nuts, so once I insert the leader of the first nut, I will open the leaders option list and I will select the Add Leader option. I will select the leader of the nut and notice that another leader with an arrowhead appears. Both leaders are connected to the word nut. I will click on the top view of the second nut to place it. To change the position of the leader, I will select it and click on the grips. I can adjust its position by moving the cursor accordingly. When I'm satisfied, I will click again to place the leader to the new position. There are several grips I can use to adjust each part of the leader just by clicking on them and moving them to a new position. To remove the second leader, I will reopen the Leaders option list and select the Remove Leaders option. Then I will select the multi-leader I previously created and I will press Enter. The second leader was removed automatically. I will click on the Undo button to restore the multi-leader and move on to show you how to modify the leader styles. First, I will open the Multi-Leader Style Manager window. I can open this window if I expand the Format menu, or if I expand the Annotation panel of the Home ribbon and click on the Multi-Leader Style icon. Either way, the window with all the available styles appears. I will select the standard style, which is the one that was used, and click on the Modify button. In the first tab, I can change the leader type from straight to spline. I can even remove the leader line if I want to. In this example, I will select the spline. Now look how the preview changed. Right below, there are three fields that also have to do with the leader: the color field, the line type field, and the line weight field. I can change the leader's color, line type, and the line's thickness if I want to. However, in this case, I will only change the color to cyan. Next, I will change the arrowhead symbol from the list. I will select the open arrow and change its size to 2.5 from the size field below. Then I will move to the Content tab to make some changes to the text. First and foremost, I will change the text color to cyan and then the text size to 3. I can add a frame around the text by activating the Frame Text checkbox. I can also change the text angle if I wish, but in this example I will not do it. Another important field is the landing gap, which defines the distance between the text and the leader line. I will set this value to 1 and then I will look in the preview. Once I'm satisfied with the result, I will click OK to close this window, and I will also close the Multi-Leader Style Manager window. At this point, I will select all the leaders and delete them in order to replace them with the new type of leaders I have created. As I mentioned in the beginning of the lesson, those are the parts of an assembly. Each part in assemblies is represented by a different number as is shown in the image. To insert balloon leaders like the ones in the image, I will expand the Annotation panel of the Home ribbon and open the drop-down menu of the leader styles. From the available styles, I will select the balloon style. Next, I will open the Multi-Leader Style Manager window, select the balloon leader style, and click on Modify. I can change the multi-leader type from the Content tab to Block. If I expand the drop-down list of the Source Block field, I can find a variety of blocks and shapes such as slots, hexagons, and circles. From the available options, I will select the circle and then I will click OK. I will also close the Multi-Leader Style Manager window and proceed to insert the first balloon leader. The first part is the pulley, which is the item number 2, so I will activate the leader tool and click to place the arrowhead. Once I click to place the leader line, the Edit Attributes window appears automatically. I will type the number 2 in the Enter Tag Number field and click OK. Notice that a bubble leader with a number 2 in it was created. In the same way, I will insert the rest of the leaders one by one. In case I want to change the number of a leader, all I have to do is double-click on it and the Edit Attributes window will reappear. I can change the number of the tag and click OK. The number changed automatically and now the leaders have been placed right. Up to now, we have learned how to insert dimensions and leaders and, most importantly, how to modify them. However, it is highly recommended that you do not modify the existing styles. In every drawing, we can create as many new annotation and leader styles as we wish, and we can even insert those styles from Design Center in different drawings. As you can see, I have opened one of my existing drawings. I will expand the Annotation panel of the Home ribbon and open the Dimension Style Manager. Let's say I wish to create a dimension style based on the standard style. I will select the standard style and click on the New button. The Create New Dimension Style window appears. In the New Style Name field, I will type the phrase Architectural Style and then I will click on Continue. Now that the name was set, the New Dimension Style window opened and I can modify the dimension style as I wish. I will start by changing the precision from the Primary Units tab to 2 decimal places. Then, I will move to the Text tab and change the text alignment to align with the dimension line. Next, I will activate the Symbols and Arrows tab and change the arrowhead type to Architectural Tick. Finally, I will return to the first tab, which is the Lines tab, and I will set the fixed length for the extension lines and the extent beyond ticks value to 0.3. Now I will click OK to save the changes in this style and notice that the new style I created has been added in the list. I can make this dimension style the current style if I click on the Set Current button. I will also close the Dimension Style Manager window to create a new leader style tool. I will expand the Annotation panel of the Home ribbon once again, and this time I will click on the Multi-Leader Style icon. Once the Multi-Leader Style Manager window opens, I will select the standard style and click on the New button. I will change the name of the new leader style to Detail Callout, and then I will click Continue. The Modify Multi-Leader Style window opens, so I can make some changes to this leader style. In this example, I will go straight to the Content tab and change the leader type to Block. From the available blocks, I will select the Detail Callout, and I will also change the scale to 50. Now I am ready to click OK and set this leader style as the current style before closing the Multi-Leader Style Manager window. At this point, I will place a linear dimension and a callout detail leader to see the result. When I insert the callout detail leader, I have to specify the attributes of this leader, which is the view number and the seat number. In this example, I will not insert values in those fields and I will just click OK. As long as I have saved the file and closed the application, I can insert the dimension and leader styles of this drawing into a new one or an existing one from the Design Center. In some cases, we may need to create tables to indicate certain information about our drawings. For instance, in a previous lesson, we used bubble leaders to indicate the different parts of an assembly. However, as you can see, the only information those leaders give us is the number of the part. In order to show more information about its part, I can create a table which will contain the name of its part, the number that the part is represented by, and how many are used in the assembly. To create a table, I can either open the Draw menu, or I can click on the Table button in the Annotation panel of the Home ribbon. Once I click on the table icon, the Insert Table window appears with all the table settings. In the column and row settings, I can specify how many rows and columns the table will have. In this example, I will set the number of columns to 3, one for the part number, one for the name, and one for the quantity. So I will change the value in the columns field to 3. As for the column width, I will set its value to 40. Next, I have to specify the number of the rows. Before I do that, I want you to notice that the field of rows is called Data Rows. Tables in AutoCAD have at least 3 rows, even if I set the value in the Data Rows field to 1. If you look below this section, you can see the Set Cell Style settings, which defines if the first row will be a title row, a header row, or a data row. The same thing happens with the second row. Then there are the same 3 options for all other row cell styles, which apply to the number of rows I have specified in the Data Rows field. As a result, you have to specify 2 rows less than the actual number of rows you wish the table to have. To get a clearer idea of how this works, let's say that I need a table with 8 rows in total. I will set the value of Data Rows to 6 and change the first row cell style to header since I do not wish the table to have a title. Next, I will also change the second row style to data. In the All Other Row Cell Styles, I will also set the data style. Before I click OK, I should mention that I won't specify a value in the row height field because the row height is being adjusted according to the size of the letters. At this point, I will click OK, and as you can see, the table moves along with the cursor until I click again to place it. Once I place it, I will start typing the first header, which is the item number. I can modify the text appearance and justification from the text editor ribbon like we have learned in previous lessons. By pressing the Tab button, the cell next to the one I edited activates. This time I will type the word description and then I will press Tab again to write the last header, which is the quantity. I will close the text editor and double-click on the cell under the item number. I will type the number 1 and then I will press Enter to move to the cell right below where I will type the number 2. I will continue typing numbers until I reach the last cell of the column and write the number 7. Then I will fill the second column with the name of its part. The number 1 represents the bushing. Once I write the word bushing, I will press Enter to move to the cell below and write the name of the second part. The second part is the pulley, so I will type the word and press Enter again to move to the name of the next part, which is the bracket. The fourth part is the washer. The fifth, the turn screw. The sixth, the cap screw. And lastly, the seventh, the nut. Once I write each of them in the right cell, I will move on to the quantity. All the parts apart from the nut are used in the assembly once. So I will type the number 1 to all the cells of the column except the last one. Since there are 2 nuts in the assembly, I will type the number 2 in the last cell. Now, in case I want to align the cell contents evenly, I have to select all the cells I wish to align differently first. When I select the cell of the table cell ribbon appears. From the Cell Styles panel, I will select the middle centered justification and notice how the table changes. At this point, I should mention that we can insert or delete rows and columns from the Table Cell ribbon. For example, I will select the C8 cell and I will insert 2 rows below the 8th line. Similarly, I could have added more columns. Before we finish the lesson, I should mention something quite useful. We can select several neighboring cells and merge them. In this example, I will select the cells of the 9th and the 10th row, then I will expand the Merge options, and I will select Merge All. Notice that those 6 cells became 1. If I wish to separate these cells again, I can just click on the Unmerged Cells button. Finally, I will delete these 2 rows I created to show you the Merge and Unmerge options. In the previous lesson, we learned how to create an empty table and fill in its contents afterwards. Another way to create a table is to use the contents of an existing Microsoft Excel file. As you can see in the open document, an apartment's layout has been created and the necessary dimensions have been added. At this point, I will open the file I have created in which the area of each room as well as the total area of several apartments have been calculated. Notice that each apartment's total area has been calculated using a function. At this point, I am interested in the data concerning the apartment 1, which means I will only need the data from the cells B3 to C11. I can create a table in AutoCAD using this data by creating a link through the AutoCAD file and this Excel file. This means that every time I make a change, either in the table in AutoCAD or in the Excel file, I can either upload the changes from AutoCAD to Excel or download those changes from Excel to AutoCAD. Simply put, I can update either table automatically without having to worry about keeping track of every change I make. So without further ado, let's see how we can create a table in AutoCAD using a data link. All I need to do is to go to the Annotation panel of the Home ribbon and click on the table icon. Once I click on the table icon, the Insert Table window appears. From the Insert options, I will select from a data link and notice that the list right below activates. However, since I have not created any data links yet, the phrase No Data Links Found appears. To create a link, I will click on the Launch the Data Link Manager icon. Once I do that, the Select Data Link dialog window appears. I will click on the Create New Excel Data Link option, and automatically the Enter Data Link Name window pops up. At this point, I should mention that it is required to save the AutoCAD file before you try to create a link. So I will enter the phrase Apartment1 dash Area Data, and I will click OK. As soon as I click OK, another window appears so I can specify the Excel file from which the table will extract the data. I will click on the Browse for a File icon in order to browse my folders and select the file. In this example, I will go to Desktop, select the Apartments Areas file, and then click Open. As you can see in the preview, if I click OK now, the data of every apartment will be included in the table. However, as I said before, I am interested only in apartment 1. So from the link options, I will select the Link to Range option, and I will type B3:C11 in the field right below. Once I click on the preview, notice how the preview changed accordingly. I also want you to notice that the formatting of the cells does not change. In other words, the text colors, the cell colors, as well as the merged cells in Excel will still appear the same way in AutoCAD. Now I will click OK to save the changes in the data link. I will also click OK to close the Select a Data Link window. And finally we'll click OK to close the Insert Table window. As you can see, the table moves along with the cursor until I click to place it. I will place it under the floor plan. At this point, I will make some changes in the Excel file, and then I will proceed to update the table in AutoCAD. So I will open the Excel file and change the first apartment's kitchen area from 16 square meters to 20 square meters. Naturally, since the total area is calculated through a function, it changed automatically. I will save the changes in Excel and then I will return in AutoCAD. The table's contents remained the same, but a warning appears on the right lower side of the application, which informs me that the data link has changed. To see the changes in AutoCAD 2, I have to go to the Linking and Extracting panel of the Insert ribbon and click on the Download from Source button. Then I have to select the table and press Enter. Notice that the data were updated as easily and as simply as that. This time I will change the corridor's area from 2 square meters to 6 square meters in AutoCAD. To do that, I have to select the B6 cell and unlock it first. The moment I selected the cell, the Table Cell contextual ribbon appeared. I will go to the Cell Format panel, and from the Cell Locking drop-down, I will select the Unlocked option. Now I can double-click on the cell and change its content. I will delete the number 2 and replace it with the number 6. Notice that even though I changed the area of a room, the total area did not change. This happens because there is no function in the B9 cell of AutoCAD's table. The number you see is just a number. So, to correct that, I have to upload the changes to the Excel file and then download the changes to AutoCAD again. So I will close the Excel file and then I will return to AutoCAD. Next, I will go to the Linking and Extracting panel of the Insert ribbon and click on the Upload to Source button. I will select the table and press Enter. Now it's time to open the Excel file again. Notice that not only did the corridor's area change, but the total area increased as well. Back in AutoCAD, I will go to the Linking and Extracting panel of the Insert ribbon and click on the Download from Source button. Then I will select the table and press Enter. As you can see, now all the data is correct. Once we have finished a drawing, it is highly possible that we would like to print it. In this example, an architectural drawing has been created in millimeters. I can print it directly from Model Space if I click on the plot icon in the Quick Access toolbar, or if I expand the File menu and select Plot. Alternatively, I can click on the AutoCAD icon and select the Print option. In this example, I will click on the plot icon in the Quick Access toolbar. Since, apart from the Model tab, there are two extra layout tabs, a message appears asking me if I wish to plot multiple sheets. However, I only wish to plot the drawing that is shown in the model, so I will select the Continue to plot a sheet option. Automatically, the plot model window appears. Firstly, I have to select a printer, so I will expand the drop-down menu, and in this example, I will select the DWG to PDF option. Next, I have to specify the paper size. Since I want to print my drawing in an A4 paper, I will search in the options of the list and I will select the ISO A4 size. Then I have to specify which part of the model space will be printed. So in the plot area, I will expand the list and I will choose the window option. The plot model window disappears automatically to allow me to select the area that will be printed directly from the model space. Now all I have to do is create a rectangular area by specifying its two corner points like I would do if I created a rectangle. So I will click on the upper left corner and then on the lower right corner of the drawing area, making sure that all the views are completely enclosed in the rectangular area. Once I clicked to specify the second point, the plot model window reappeared. From the plot offset options, I will activate the Center the Plot option so the drawing will be printed in the center of the paper. From the plot options, I will make sure that plot object line weights as well as the plot transparency are selected. If I unselect those two checkboxes, the thickness of the lines and the transparency will be ignored. Then I will also specify the drawing orientation. In the current example, I will select the landscape orientation. Next, I have to specify the scale. For this reason, I will deactivate the Fit to Paper option. Once I do that, the scale field becomes active, so I will expand the drop-down menu and select the 1 to 100 option. At this point, I will click on the Preview button to see the result before I proceed to print it. As you can see, with this scale set, the drawing doesn't fit to the paper, so I have to either change the paper size or the scale of the drawing. I will close the preview and in this example, I will change the scale to 1 to 150. However, this option is not available in the list. In this case, I will use the fields under the list to specify the scale manually. I will set the units value to 150, so 1 mm on the paper will correspond to 150 drawing units, and click on the preview again to see the result. This time the scale seems fine, so I will close the preview again, and finally I will click OK to print the drawing. Since I am printing the drawing in PDF, I will have to select a folder to save it. I will open the desktop folder and save it with the suggested name. After a few seconds, we can see the result. Another way to plot our drawing is to use a layout. Layouts are 2D working environments for creating drawing sheets. Every new AutoCAD drawing has by default two layouts that are shown as tabs next to the Model tab. I can add more layouts by clicking on the plus icon, and I can also rename its layout if I right-click on it and select the Rename option. I will right-click on the Layout 1 and I will select Rename. Then I will type the name A4 size and press Enter. Notice that its name has changed. Similarly, I can delete a layout if I right-click on the layout's name and select the Delete option. In this example, I will delete the third layout I created previously. A warning appears to inform me that the selected layout will be deleted. I will click OK to delete this layout. At this point, I will click on the A4 size layout to open it. As you can see, there is a wide area. This area is called paper space, and I can display scaled views of the model space within layout viewports, create tables, schedules, notes, and even insert dimensions for my drawing. As for layout viewports, they are objects that display views of the model space, and as you can see, there is already one in this layout. The first thing I should do is select this viewport by clicking on it and delete it. So I will press the delete button from my keyboard, and once I do, it disappears. Now I need to make the necessary changes in the paper. So I will right-click on the A4 size layout tab, and I will select the Page Setup Manager option. The window Page Setup Manager opens, containing a list with all the existing layouts of the drawing. This window also displays the basic settings of the selected layout. Currently, the A4 size layout is selected, and since I haven't set up the paper yet, most of the setup details are not defined. I will click on Modify to open the Page Setup window. Firstly, from the Printer-Plotter section, I will expand the Name Fields drop-down menu, and I will select the DWG to PDF option. Next, I have to specify the paper size. Since I want to print my drawing in an A4 paper, I will search the option of the paper size list and select the ISO A4 option. I will make sure that from the plot options, the Plot Object Line Weight and the Plot Transparency checkboxes are selected, so the thickness of the lines as well as the transparency will be printed. In case I wished either of these properties to be ignored, I could just unselect the corresponding checkbox. In the next step, I will set the drawing orientation to landscape. Finally, I have to specify the scale of the paper. I will select the millimeters option from the drop-down menu since I'm drawing in the metric system. Now I have to specify the equivalent of the units I used in the drawing relatively to millimeters. Since I drew in millimeters, 1 unit will be equal to 1 millimeter. In case I had drawn in centimeters, 1 unit would be equal to 10 millimeters, since 1 centimeter is equal to 10 millimeters. And if I had drawn in meters, 1 unit would be equal to 1000 millimeters, because 1 meter is equal to 1000 millimeters. It's really important to specify the scale of the paper correctly because the paper is being adjusted according to this scale. So once I have finished setting up the page, I will click OK to close the Page Setup window. Notice that the basic settings of the selected layout have now changed. At this point, I will also close the Page Setup Manager. I can insert one or multiple viewports in the layout, but before I insert anything, it's really important to check if the insertion scale units that were specified in the model coincide with the ones I specified in the Page Setup window. So I will open the Format menu and select the Units option. Notice that the insertion scale units are indeed set to millimeters, so I will click OK to close the window and move on to insert a viewport. I can insert a viewport in several ways, however, the simplest one is to click on the rectangular button that can be found in the Layout Viewports panel of the contextual ribbon. Once I click on it, all I have to do is create a rectangular area by specifying 2 corner points like I would do if I created a rectangle. So I will click on the upper left corner and then on the lower right corner of the layout, and notice that the viewport was inserted. Finally, I can set the scale of the viewport by selecting the viewport and expanding the scale list that appears in the status bar. From the available options, I will select the 1:100 scale option. As you can see, this scale doesn't have the desired result, so I'm going to change the scale again. If the scale I want to select does not exist among the available options, I can always create it if I click on the Custom option. The Edit Drawing Scales window opens automatically. I will click on the Add button to add a new scale. In the name field, I will type 1 to 150, and in the scale properties I will specify 1 paper unit to be equivalent to 150 drawing units. Then I will click OK. Notice that this option is already added in the list. I will also close the Edit Drawing Scales window and I will select the viewport again. Now I will expand the scale list and I will select the 1 to 150 option that I just created. At this point, I will double-click inside the viewport and I will use the Pan tool to move the drawing to the center of the viewport. I should mention that while being inside the viewport, I should be careful not to zoom in or out because the scale will change. I will double-click somewhere on the paper or on the gray area to exit the viewport. Now I will select the viewport once again and change its layer from the Home ribbon. If we look at the Layers panel, we can see that the viewport was inserted in the Walls layer, which was currently active. I will open the layer list and move it to Layer 1. This is a viewport that cannot be printed since I have deactivated the plotting option. In this way, the frame of the layout won't be printed. Lastly, I should mention that I can add dimensions or text objects in the layout. For instance, if I wish the scale that I have set to the layout to be shown, I can create a text object and write the exact scale that has been used. Once I write the text and close the text editor, notice that the text is too small, so I will double-click on it, select it, and then change its size to 3. Then I will close the text editor again and click on the grip to move the text in the right position. At this point, I'm ready to print the layout, so I will click on the plot icon from the Quick Access toolbar. Since there are more layout tabs and the Model tab, a message appears asking me if I wish to plot multiple sheets. However, I only wish to plot the active layout, so I will select the Continue to Plot a Sheet option. The settings in the plot window have already been adjusted according to the Page Setup Manager, so all I have to do is click OK. I will save the layout in Desktop under the name A4 size. After a few seconds, we can finally see the result.